सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिस्ततां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः
Jyoti Param Jyoti, Deepa Jyoti Janardana. The flame of a lamp signifies the path from darkness to light and from ignorance to knowledge. Now I request the dignitaries on the dais to kindly light the Kuttuvelak. Thank you, sir. Now I invite Professor M. Devika, Head Department of Mathematics, to deliver the welcome address.
Jai Shri Krishna. Good morning to the esteemed members on the dais, heads of various departments, teaching faculties, research scholars, and postgraduate students of various institutions and students of DDGD Vaishnav College present here today for the inaugural function of 4th International Conference on Mathematics Nexus and Emerging Applications, ICMNEA 2026, organized by the Postgraduate and Research Department of Mathematics, DDGD Vaishnav College. It's my privilege to welcome Shri Ashok Kumar Mundraji, Secretary, DDGD Vaishnav College, Chief Patron of ICMNEA 2026, and Shri Ashok Kediaji, Treasurer, DDGD Vaishnav College. It gives me immense pleasure to welcome Dr. S. Santosh Babu, Principal, DDGD Vaishnav College, Syndicate Member, University of Madras, Patron and Convener of ICMNEA 2026. It gives me immense pleasure to welcome Dr. S. Seshadrinathan, Principal in Charge, DDGD Vaishnav College, Associate Professor and Head, Department of Commerce, for the presence here. And thank you, sir, for your support and guidance throughout this academic year. On this occasion, I thank our dynamic principal and principal in charge for the support and guidance given to us in all our academic and research activities. It's my privilege to welcome our chief guest, Dr. Suresh Rasappan, Professor, Department of Mathematics, University of Technology and Applied Sciences, IBRI, Oman. Sir is a dedicated researcher and educator with over 2 decades of teaching experience in the field of applied mathematics, control systems engineering, and consistently demonstrated a commitment to advancing the boundaries of mathematical modeling and its practical applications in real-world complex systems. Above all, when we approached Sir to be the chief guest for today's inaugural function and as well as to deliver a talk on the international conference, Sir immediately accepted in spite of his busy schedule and traveled all the way from Oman, which shows to be present here today, which shows his commitment, dedication, and passion for mathematics. Thank you, sir, for your gracious presence in this international conference. And I thank sir for the talk on, to deliver a talk on the topic linear algebra in AI, enhanced image processing, which is very essential in today's AI generation, which is very, very important also for the research scholars and postgraduate students who are going to pursue research in this particular field. During this academic year 2025-2026, the Brahmaganit Club of Postgraduate and Research Department of Mathematics conducted student induction program, investiture ceremony, seminars, workshops, guest lectures, skill training program, counseling session for parents, industrial visit to Chennai Mathematical Institute and Institute of Mathematical Sciences, and celebrated National Mathematics Day and organized Math Cypher 2026, an intercollegiate event. Also, department achieved an academic important significant milestone by being recognized for the first time as one of the designated test centers for Madhava Mathematics Competition, which is a prestigious national level examination for undergraduate students organized by Bhaskaracharya Pratisthana Pune and funded by National Board for Higher Mathematics. During December 2025, an initial meeting was convened on signing of MOU between DDGD Vaishnav College and University Technology Petronas, Malaysia. The meeting was presided over by Principal and attended by Dr. Mohana Sundaram Muttuvelu, Professor, University Technology Petronas, Malaysia, along with heads of various departments like Department of Data Science, Department of Computer Science, Department of BCA, Department of Statistics, Department of Max with CA, and conveners of various academic cells and faculty members. Subsequently, in Jan 2026, second meeting was held with Dr. Vijent Sagayam Asirvadam, Associate Professor, Department of Fundamental and Applied Sciences, University Technology, Petronas, Malaysia. The discussion focused on academic and research collaboration through student exchange, joint research initiatives, faculty exchange, collaboration with respect to conference publications. And it was resolved to proceed with formal drafting, marking a significant step towards international academic collaboration. At this juncture, it's my privilege to welcome Dr. Vijent Sagayam Asirvadam for accepting our invitation to deliver an invited talk in today's conference. It gives me immense pleasure to welcome Dr. K.C. Sivakumar, Professor, Department of Mathematics, Indian Institute of Technology, Chennai, Dr. N.C. Ganegowda, Professor, Department of Mathematics, University of Sri Jayawardhanepura, Sri Lanka, Dr. Kanchana C., Researcher, Institute for Advanced Research, IA, Sedana, University of Tarapaco, Arica, Chile, Dr. Sadagopan N., Associate Professor, Indian Institute of Information Technology, Design and Manufacturing, Kanjipuram, Dr. J. Bhaskar Babuji, Professor and Head, Department of Applied Science and Humanities, MIT Campus, Anna University, Chennai. I welcome and thank all the professors for generously accepting our invitation and for their presence in ICMNEA 2026. With the participation of eminent professors of international repute, this conference will be intellectually stimulating and enriching for all the research scholars and students. With a rich history of academic excellence and a commitment to nurturing mathematical talent, the department is initiating Ganita Circle on this auspicious occasion to inculcate among school students about mathematics and its application in the real world. To spread this awareness, we have with us alumnus of our department, Mr. Srinivas, Assistant Headmaster of Velamal School, Mogapet, and Mr. Balaji Arumugam, teaching mathematics at Chaitanya School, Nolambur. I welcome Mr. Srinivas and Mr. Balaji Arumugam. Through this Ganita circle, the department is planning a series of academic activities like conducting online quizzes, organizing mathematical modeling exhibition in our college campus for school students, and many more. Today's international conference is the final program of our department for this academic year 2025-2026 and marks the beginning of Ganita Circle, which will benefit the students who are going to choose mathematics as their core subject. Once again, I welcome you all to the 4th International Conference on Mathematics, Nexus and Emerging Applications, ICMNEA 2026. Thank you all.
Thank you, Madam, for your gracious and warm words of welcome. Now, moving on to the felicitation ceremony. Honoring excellence is a tradition and fuels inspiration. I now invite our Principal in Charge, Dr. S. Seshadrinathan, Head, Department of Commerce, to felicitate our Chief Guest with a shawl, memento, and nut box as a token of our deep appreciation.
Come on, give a big round of applause.
Now I invite Professor Devika to felicitate the Principal in Charge, Seshadrinathan sir. Thank you, sir. May I now request our Principal in Charge, Dr. S. Seshadrinathan, Head, Department of Commerce, to deliver the presidential address and share his insights on the evolving landscape of mathematics.
Jai Shri Krishna. Energy level should be really fantastic. Jai Shri Krishna. Apara Karuna Sindhum Yanadam Shantarupinam Shri Chandrasekhara Gurum Pranamami Mudhanvakam Guroho Anugrahena Eva Puman Purna Prashante. I am really delighted to be part of international conference conducted by the Maths Department of DG Vaishnav College. Mr. Gentleman, Dr. Suresh Rasapan, all the way from Oman has come here. Head of the department, Madam Devika, other faculty members. I am very happy to people have come, alumnus, passed out of Vaishnav has come from schools, and my dear students. In this world, anything can be achieved only by the Almighty's grace and Gurunathal's grace. This particular department has got a rich tradition. I have seen, my association with this college is 43rd year. I have seen some stalwarts in this department. Professor Ramasubramaniam, Professor Seshasai, Professor Rajaya, Srinivasan. Genius were there in fact. Those days, they did not have any facility. No auditorium, no conference hall, seminar hall, nothing. They were confining themselves only with the classroom teaching. Nowadays, the management is magnanimous. They have constructed a lot of auditorium, seminar hall of this nature. Therefore, order of the day, we have to conduct programs. But conducting, how many people are going to get the benefit out of it? That is a $1,000,000 question. How many students are going to give their heart and soul to it? That is a $1,000,000 question. Last week we had our conference, 2 days conference in fact. We have called four people from IIM, Ahmedabad, Bangalore and all, 4 chartered accountants and 6 CFOs. How many students really showed so much of interest? It's a big question mark, big question mark. Therefore, my dear students, organizing is not important. How effectively you are going to make use of it, that is important. From the beginning till the end, you have to apply your mind, involve yourself. Every session is going to be online or offline. Ask as many questions as possible. Any conference is complete only when there is going to be a fantastic participation from the students. The dialogue should not be monologue. It should be really both ways. It should be have the participation. Therefore, ask questions. Don't have any hesitation. What my friend will think about me if I am going to ask question. Even the faculty members also. For all the speakers, I will be the first person to ask question. I will not simply leave them. Because how difficult to organize, all of you know. Funds. With money, can you achieve anything? Getting people. As said by someone, someone, Arulillarka Ulaghamille, Purulillarki Ulagamille. In fact, getting people. Therefore, nothing is powerful in this world than knowledge. Now, slightly a change. It's not knowledge alone, applied knowledge, especially in the field of mathematics. AI is doing a tremendous job. All the fields. AI is going to eat away the employment opportunities of thousands and lakhs of people. When you are not going to be competitive, when you are not going to be really having the fighting spirit, when you don't have drive in your belly, you will be out of the race. Our days are all gone. Because in our days, we did not have much of competition. We are not tech savvy people, as far as I am concerned. But present day generation, they are tech savvy. Extraordinary talent and ability you have, in fact. You have to compete. Therefore, I congratulate the Department of Mathematics for organizing this international conference. The one-day program should be really a wonderful one, in fact, provided if you show interest. I don't want to take much of time of this gentleman who is going to address, in fact. Once again, my congratulations, appreciation to the department. Thank you so much for the opportunity.
Thank you, sir, for your encouraging words and for setting a scholarly spirit for this conference. Now, going on to the most awaiting moment, the release of ICMNEA 2026 conference proceedings. This book contains all the hard work and research shared by our scholars today. I kindly request our chief guest, Dr. Suresh Rasapin, to release the proceedings, and I request our principal in charge to accept the first copy. The Department Club, Brahmaganit, under the expert guidance of our faculty coordinators, has compiled the annual newsletter, Math File. I request our chief guest to release the newsletter, and I request our principal in charge to accept the copy. The strength of the conference is defined by the caliber of its mentors. It's now a pleasure to introduce our chief guest, Dr. Suresh Rasappan. It's my great privilege to introduce our chief guest for today's program, Dr. Suresh Rasappan, an eminent academician, researcher, and mentor in the field of mathematics. He is currently serving as a senior lecturer at the University of Technology and Applied Science, Sultan of Oman, since October 2021. With over 2 decades of rich teaching experience, he has held several prestigious academic positions in India and abroad. He previously served as a professor, associate professor, and head of the department at Tech University, Chennai. He has completed his PhD Mathematics from Tech, Chennai in July 2013. His doctoral research focused on global chaos synchronization of chaotic and hyperchaotic systems, reflecting a strong foundation in nonlinear dynamics and mathematical modeling. He also holds an MPhil in mathematics from Bharatiyar University. A dedicated research supervisor, has successfully guided several PhD scholars in diverse and socially relevant areas such as mathematical modeling of mosquito life cycles, HIV population analysis, nitrogen mass cycle models, chaotic neural networks, etc. His mentorship has significantly contributed to interdisciplinary research, bridging mathematics with biology, healthcare, and engineering. His research excellence is further demonstrated through multiple funded projects in Oman, including innovative works such as ScienceSpeak, empowering Oman Sign Languages with deep learning technique, MathSphere, personalized AI learning, AI-driven healthcare prediction systems, and the establishment of mathematics lab for practical learning. This project highlights his commitment to integrating mathematics with artificial intelligence and real-world applications. He was also a recipient of Summer Research Fellowship in Ordinary and Partial Differential Equations from the Indian Academy of Sciences. To his credit, he has numerous research publications indexed in Scopus, Web of Science, reflecting his consistent scholarly contributions to the global research community. Dr. Suresh Rasappan is not only a distinguished researcher, but also an inspiring educator who believes in innovation, interdisciplinary collaboration, and academic excellence. On behalf of the institution, it's honor and privilege to welcome you, sir. So we are delighted to have you, we are very much delighted, and you can start your session now, sir.
இல்லைங்க ஆடியோ சரி இல்லை சொல்லுங்க. Hi, good morning to all. How are you? Fine. I am not going to teach today any new theorems, any new proofs, and all the things. My motive is very simple. So we are playing with our mobile phones, or we are playing the videos, images, and all the things in day-to-day life. Am I right? Yes or no? How to deal and how they are doing by using the linear algebra. Simple concept. நான் உங்களுக்கு ஏதாவது ஒரு புதுசாக தியரமோ இல்லை உங்களுக்கு ஏதாவது ஒரு ப்ரூஃபோ கொடுத்து நான் உங்களை வந்து இன்னைக்கு வந்து போர் அடிக்க போகிறது இல்லை. The simple. Our sixth finger, that is our mobile phone, we are playing with all our mobile phone and generative AIs. We have that if the teachers are giving any assignment or what are the things, we just keep it in ChatGPT and we are bringing solution. Am I right? Yes or no? Yes. Then we are famed with photos, selfies, keeping our photos in WhatsApp status. Yes or no? கொஞ்சம் ரிப்ளை பண்ணுங்க. வைக்கிறோமா? Okay. So we are all using that. What max behind that? Color change பண்றீங்க, photo edit பண்றீங்க, video edit பண்றீங்க, text sequence input-ஆ கொடுக்குறீங்க. அதெல்லாம் என்ன இருக்கு? So, simple, there is a linear algebra concept. Nothing new concept. Addition, subtraction, multiplication, division, all the things involving in that concept. So today I am going to teach only that. Okay. So color combination, computer knows or the AIs knows only the three colors. Computer knows only the three colors. RGB. கம்ப்யூட்டர் பொறுத்தளவுக்கு கம்ப்யூட்டருக்கு மூணு கலர் தான் தெரியும். ரெட் கலர், கிரீன் கலர் அண்ட் ப்ளூ கலர். So how remaining colors are coming? So that is entirely the combination, linear combination. For example, so I am showing you that the color combination. So how the color combination is doing. Okay. So look at. Yeah. Now, if 128, 128, 128, that is, if red also that is red also I keep the 128 number, and green also I am keeping 128 number, and blue also I am keeping 128 number, so I am getting the gray color. Okay, I am just moving the colors, look it, I am getting a new color. The number is 197, 128, 128. Okay, again I am moving that. So 154, 128. You look it, the colors are different. Yes or no? The computer knows only the three colors, red, green and blue. The remaining colors, how we are getting? That is a linear combination of these three colors. In Microsoft Word, we are using the different color. Yes or no? In mobile phones, suppose if anyone friends are taking screenshot the photos, we are just choosing the colors and round marking and we are sending back again. Yes or no? So how the colors are generating? The AIs, even Google, Gemini, Nano Banana, generative AIs, they are using the different type of colors. Only the three color is base. The remainings are the combination. Okay. So what matrix or what max behind that? Just a linear combination. For example, I am that changing that. You are getting the different colors. That if I am 169, I am getting this color. If I am keeping 194, I am getting this color. Suppose I am keeping 0 here. Look it. I am keeping 0 here. Look it. We have a different color. How it possible? Okay. So let's come. It's a very simple. So what max behind this? So the max behind is a simple linear combination. Okay. So color pixel is stored in RGB. The computer knows only the three colors, RGB. Okay. So the computer knows number 0 to 255. That is, if 8-bit means 2 power 8, 2 power 8, 2 power 8. Okay. So that is 0 to 255. If you start with 1, 256. The computer knows only that. Okay, so remaining colors are how they are generating in AI. So they are using the linear combination. That is, so mathematically vector C is RGP. Okay, how we are going to, yeah, E1 100. The first one is for we are using grid color. The second one is green color and third one is blue color. Okay, what is our linear combination property? A1 x1 plus A2 x2 plus A3 x3. Yes or no? The same thing here. So E1 into the red color, E2 into the red color, E3 into the blue color. Okay, so we are adjusting only the colors, and the remaining colors are we are going to take a combination, then we are getting a variety of colors. Okay, the AI is generating how many colors like this? In your mobile phone, it's automatically generating 16.7 million colors it's generating. A simple linear combination, by using a linear combination, we can generate 16.7 million. Okay, so how it come to the HD quality and more than HD quality and Blu-ray quality? So that is everything based on the bit. Everything it is based on the bit. Suppose if how the quality of the pictures are they are telling. So everything is based on this pixel. Okay, when you are purchasing a new phone or when you are buying a new mobile laptops and all the things, you are first checking what? Camera pixel, yes or no? Camera pixel, yes or no? Mobile phone வாங்கும்போது நாம எதை பார்க்குறோம் இப்ப எல்லாமே? கேமராவோட பிக்சல் என்ன? ஏன்னா என்னோட இமேஜ் என்னவா இருக்கணும்? ஹை குவாலிட்டியா இருக்கணும். கரெக்டா? அதைத்தானே பண்றீங்க? Okay, now we are going to dealing with so images. Okay, now we are going to dealing with images. Okay, so images are matrix. நாம daily phoneல வந்து photo எடுக்கிறோம். So we are sharing all the things and everything is data. We are behind with the data. Okay, now we are dealing with that images. Okay, so already I told you that how the image is going to be a matrix. First you need to know that one. Okay, first you need to know that one. So already I have some images. Okay, I am running that. Okay, so if I run, so this is my image. Okay, this is my image. Okay, so you want to see the matrix of the image and the size of the images. Okay, so I am keeping here. So now I am writing the size of image. Okay, size of image. Okay, so size of the image I am saying. So IMSO. Okay, size of image. Yeah, 256 cross 250 cross 3. Okay, so what is it speaking? Normally in matrix, what is M cross N? Normally in matrix, what is M cross N? நம்மளுக்கு ஒரு மேட்ரிக்ஸ்ல நான் எது புதுசா உங்களை தீரம் கேட்கலப்பா லீனியர் அல்ஜிப்ரால நீங்க 9th 10th 11th 12th ஸ்டாண்டர்ட் படிச்ச மேட்ரிக்ஸ்ல இருந்தா क्वेश्चन கேக்குறேன். இதுலயுமே நான் என்ன போய் கேட்க போறது இல்ல. எப்படி ஐகன் வேல்யூ ஒரு ஈக்குவேஷன் கொடுத்து கிராமர் ரூல் அதெல்லாமே கேட்கல. சிம்பிளா ஒரு மேட்ரிக்ஸ்ல எம் என்னங்கிறது என்ன? ரோஸ் அண்ட் காலம். கரெக்ட்டுங்களா? ஓகே, நீங்க வந்து அது அப்படியே இருக்கட்டும். சரிங்களா? இங்கேயும் M 250 cross 256 256ங்கிறது ரோஸ் காலம் தான். நம்பர் ஆஃப் ரோஸ் நம்பர் ஆஃப் காலம் தான். ஓகே, அப்படியே இமேஜ் ப்ராசஸிங் ஏ போலாம். அந்த 250 cross 256 என்ன அப்படிங்கிறதுனா அதாவது பிக்சல். நம்ம இமேஜ் எல்லாம் நீங்க செக் பண்ணும்போது பிக்சல் பேசியிருக்கீங்க, ஞாபகம் இருக்கா? கேமரா எத்தனை பிக்சல்னு கேக்குறீங்களா? கேக்குறோம்ல, கேமரா எவ்வளவு பிக்சல்னு கேக்குறோம்ல. இப்ப நல்லா தெளிவா புரிஞ்சுக்குங்க. நாம மேட்ரிக்ஸ்ல படிக்கிறது தட் இஸ் கால்ட் எலமெண்ட், நம்பர் ஆஃப் ரோஸ் நம்பர் ஆஃப் காலம். எஸ் ஆர் நோ? அதாவது ஒரு மேட்ரிக்ஸோட நம்மளுக்கு ஆர்டர் என்னன்னா M cross N சொல்றோம். கரெக்ட்டுங்களா? மேக்ஸ் லாங்குவேஜ்ல தட் இஸ் கால்ட் ஆர்டர் ஆஃப் த மேட்ரிக்ஸ். ஓகே, அப்படியே நீங்க இமேஜ் ப்ராசஸ் வந்துட்டீங்கன்னா அதுக்கு பேர் பிக்சல். சரிங்களா? புதுசா எதுவும் கிடையாது. தட் என்ஜினியர்ஸ் தே ஆர் டெல்லிங் த நேம் as a pixel instead of element. That is, we need to change only the language. We are mathematician, we are using the math terminology, but as a AI engineer or normal engineers in image processing, they are telling that is called a pixel. இதுதான் உங்களோட கேமரா வாங்கும்போது உங்க மொபைல் போன்ல பிக்சல் என்னன்னு கேக்குறீங்க, சரியா? ஓகே. ஸோ அதுல வந்து இருக்கு 8 பிக்சல் கேமரா, 16 பிக்சல் கேமரா அப்படிங்கிறது, கரெக்டுங்களா? ஸோ தட் இஸ் டிபெண்ட்ஸ் ஆன் த பிட். உங்களுக்கு வந்து பாத்தீங்கன்னா 250x250 சாக்ஸ்னா உங்களுக்கு வந்து 8 பிட் மொபைலா இருக்கும். தட்ஸ் ஆல். ஸோ வாட் இஸ் தட் 3? அதுதான் இம்பார்ட்டன்ட். இப்போ 256 3 அப்படின்னு வரும்போது உங்களோட இமேஜ் கலர் இமேஜ், அந்த இமேஜ் வந்து பாத்தீங்கன்னா உங்களுக்கு எப்படியா இருக்கும்? கலர் இமேஜா இருக்கும். அதுதான் மீனிங் இங்க. ஓகே. ஸோ என்னுடைய ஒரிஜினல் இமேஜ் தட் ஐ எம் மேக்கிங் ஒன் மோர் திங்ஸ். ஆக்சுவலி my first image, I am keeping the image 1. So here also I am keeping image 1 because I resize the image. Okay. So this is my original image. I am running again. So look it. Okay. I renamed it. Okay. Now let's check it. You want to see the matrix of that image. IMG. I am just keeping it. Yeah, that's all. So this is the matrix. So these are the matrix. Already I told all our images are stored in எந்த image ஆனாலும், so they are storing as a images. They are storing as a images. Store as a matrix. உங்களுக்கு எந்த ஒரு image or video or நீங்க generative AI ல கொடுக்கிற text, ChatGPT கேக்குறீங்க நீங்க, what is the solution of ax plus b equal to 5, ax minus 2b equal to 8 கேக்குறீங்களா? So that is converted as a vector. உங்களுக்கு prompt என்னவாகுதுன்னா வெக்டாரா கன்வெர்ட் ஆகி அதுக்கப்புறம் தான் உங்களுக்கு என்னவா சொல்யூஷனா மாறும். ஓகேங்களா? ஓகே. So everything is stored as a matrix. Okay. So what is this number 10, 11, 9, 8? அதோட பேர் என்ன? அதுக்கு என்ன இது? That is the depth of the intensity. Depth in mathematics we are calling that is the element. Yes or no? நீங்க மேக்ஸ்ல மேட்ரிக்ஸ்ல A11ங்கிறது என்ன? எலமெண்ட். A12ங்கிறது என்ன? எலமெண்ட். A13ங்கிறது என்ன? எலமெண்ட். அப்படியே இமேஜ் ப்ராசஸிங் லாங்குவேஜ்ல வாங்க. அதே A11, A12, A13ங்கிறது பிக்சல் இன்டென்சிட்டி. உங்களுக்கு ஒரு இமேஜோட பிக்சல் இன்டென்சிட்டி என்ன? அதுதான். So the image pixel intensity is the number lies between 0 to 255. That is 256. So we are starting with 0. So therefore 255. உங்களுக்கு அந்த மேட்ரிக் ஒரு இமேஜோட நம்பர் 0ல இருந்து 255 வரைக்கும் இருக்கும். What is the name of that 9, 10, 11 அதெல்லாம்? அது வந்து பாத்தீங்கன்னா உங்களோட கலர், ஒவ்வொரு கலருக்கும் ஒரு ஃப்ரீக்வன்சி இருக்கும். சரிங்களா? ரெட் கலர்னா அதுக்கு ஒரு ஃப்ரீக்வன்சி நம்பர் வச்சிருக்கோம். நாம இங்க இப்ப பார்த்தோம்ல 255 to 128 128 128னா கிரே கலர், 000 னா ஒயிட் கலர், 255 255 255னா ரெட் கலர். So this is all called the frequency of that each color. Frequency of the each color. Okay. இப்போ ஏதாவது ஒரு இமேஜை வந்து நீங்க இன்புட்டா கொடுக்குறீங்க, உங்களோட மொபைலுக்கோ இல்ல உங்களோட ஏதோ ஒரு சாஃப்ட்வேருக்கோ நீங்க கொடுக்குறீங்க. அந்த மொபைலோ அந்த ஆப்போ இல்ல அந்த சாஃப்ட்வேரோ அது கலர் இமேஜ் தான் தெரியுமானா, that does not know the color image. அந்த கம்ப்யூட்டருக்கோ இந்த சாஃப்ட்வேருக்கோ it does not know it is color image. So we need to know about 2 more images, that is gray images, and the next one is the binary images. So in the AI, even the medical image or in space tech or in our day-to-day life, so we are dealing with more how to deal with the input. Probability எதுக்கு அப்படின்னு பார்த்தீங்கன்னா taking a decision. First linear algebra, second calculus of variation. Calculus of variation எதுக்கு அப்படின்னா optimization பண்றதுக்காக. So which one is best, which one is not best, choose பண்றது. to 100 0 to 100 அப்படிங்கிறது உங்களோட நம்பர் 0 to 1 வரைக்கும் இருக்கிற அந்த நம்பரை பர்சன்டேஜா கன்வெர்ட் பண்ணிடுவாங்க. அப்படி இல்லைன்னா சேம் டே அப்படியே வச்சிருப்பாங்க. சரிங்களா? ஓகே, இப்போ நெக்ஸ்ட் we are going for subtraction. ஓகே, இதுலயே வந்து பார்த்தீங்கன்னா one more technique I have. ஓகே, so just we are adding a one small concept. ஒரே ஒரு சின்ன கான்செப்டை மட்டும் உங்களுக்கு ஆட் பண்ணிட்டு வரனால பிரைட்னஸ் வருதுன்னு சொல்லிட்டோம். உங்ககிட்ட ஒரு இமேஜ் கிளாரிட்டி இல்லாத இமேஜா இருக்கு. சரிங்களா? யூ ஹாவ் அ அன்கிளியர்டு பிளர்ட் இமேஜ் இருக்கு. இல்ல உங்களோட ஸ்கூல் படிக்கிறப்ப இமேஜை எடுத்திருக்கீங்க, அது மேபி டியூ டு சம் புவர் மெயின்டெனன்ஸ். புவர் மெயின்டெனன்ஸ்னால நம்மளுக்கு என்ன ஆச்சு அப்படின்னா இட் இஸ் ஸ்கிராச். அந்த இமேஜை ரீஸ்டோர் பண்ண முடியுமா? எஸ். ஹவு வி ஆர் த ரீஸ்டோர் இட்? யூ கேப்சர் த பிக்சர் ஆஸ் அ 50 இமேஜஸ். நீங்க என்ன பண்ணுங்க, ஒரு 50 டைம்ஸ் நீங்க ஒரு 5 டைம்ஸ் ஃபர்ஸ்ட் இன்சிலா எடுங்க. 5 டைம்ஸ் இன்சிலா எடுத்துட்டு if you add a equal to a1 plus a2 plus a3 plus a4 plus a5 by 5, what is the meaning? Average. Average எடுத்தீங்கன்னா you are getting a clear image. A's are doing the same things. சார் நான் ஒரு இமேஜ் தானே கொடுக்குறேன், அது எப்படி எனக்கு வந்து அவ்வளவு இமேஜ் ஆவரேஜ் எடுக்குது? if I am giving the one images, if you are not giving a 50, அது என்ன பண்ணீங்கன்னா யூசர் 50 போட்டோ கொடுக்கல அப்படிங்கும்போது it randomly it consider as 50 layers or 10 layers. அது என்ன பண்ணனா அங்கங்க நாய்ஸ் வச்சு ஒரு 50 இமேஜ் அது எடுத்துட்டு ஆவரேஜ் எடுத்து it is giving a clear image. So if you want more clear images, then you can go average of the images. சரிங்களா? But if you want to brightness and darkness of the images, you just add a one simple constant c and c minus. That's all. Okay, now I am going to give one more things one. So what is that? Just little one, we going for a heading. Run the image, different image வந்து I am going to giving a I'm going to give as input. Okay, okay, so Google Memoriesல ஒரு 10 வருஷம் ஒரு 1 year உங்களுக்கு வந்து கொடுக்கும், ஒரு வீடியோ கொடுக்கும், ஒரு டெமோ வீடியோ கொடுக்கும். உங்களோட 10 இமேஜை வந்து பிளர் பண்ணி அப்படியே கொண்டு அப்படியெல்லாம் வருதுல்ல, ஒரு ஒரு மேஜிக் மாதிரி கொடுத்து உங்களுக்கு ஒரு மெமரியை ஷேர் பண்ண கூகுள். ஹவ் இட் பாசிபிள்? அது வந்து எப்படி பாசிபிள் ஆகும் அப்படிங்கிறது வந்து பார்த்தீங்கன்னா நம்மளுக்கு என்ன கான்செப்ட்? த சேம் அடிஷன் கான்செப்ட் பட் பேஸ்ட் ஆன் த வேல்யூ ஆஃப் சி. இப்போ நாம் ஒரு சியை யூஸ் பண்ணோம்ல, சி பிளஸ் ஆல்பா இன்டூ 1 மைனஸ் சி. சேம் அதே மேட்ரிக்ஸ், ஒரே இமேஜ், 2 இமேஜஸை ஒரு 2 டைம் உங்களுக்கு அடிஷன் பண்ணி உங்களுக்கு வந்து பார்த்தீங்கன்னா 2 இமேஜை வந்து மிக்ஸ் பண்ணி கொடுக்கும். ஸோ ஐ ஆம் ஷோயிங் த டெமோ, தென் யூ கம் டு நோ ஹவு தட் கூகுள் இஸ் பிளேயிங் வித் யுவர் ஓன் ஃபோட்டோஸ். ஓகே, இப்போ எனக்கு 2 இமேஜை வந்து ஓப்பன் கொடுக்கணும், இமேஜ் கொடுக்கணும். ஓகே, ஓப்பன் இமேஜ், ஐ ஆம் கிவிங் மை ஃபர்ஸ்ட் இமேஜ். ஓகே, ஐ ஆம் கிவிங் மை ஃபர்ஸ்ட் டெஸ்ட் இமேஜ் 1. ஓகே, so I am giving my second image. Okay, so this is the first image. Okay, first images, this is the formula, blending. Okay, so instead of I am using C, I am using that alpha. Okay, the next I am going to give my second images. Okay, so second images I am going to give this one. Okay, look at here. This is my second images. Yes or no? As of now, so you look it. So the first images and second images both is mixed here. Both images mixed here. Okay, so I am giving the alpha value is completely the 50. So now you can look it here. Completely 50. Yeah. Now you look here. You are getting here also the second image. இங்க எனக்கு என்ன கிடைக்குது செகண்ட் இமேஜ் தான் கிடைக்குது ஓகே இப்போ நான் அந்த ஆல்பா பாருங்க என்ன பண்றேன் so I am giving this to that 0 okay instead of the 1 I am giving a 0 so look it here it take a time because it want to process look it here what you are getting it is a image 2 look it this is all image 1 so no issues you look at here I gave it 2 images so based on the alpha value it is creating a 2 images இதத்தான் உங்களுக்கு இங்க ஆல்பாங்கிறது வந்து I am using the blender இங்க ஆல்பாங்கிறது இயர் உங்களுக்கு இந்த டேட்ல இருந்து இந்த டேட் வரைக்கும் கூடிய இயர் ஓகே it is fixing that that Google have some fixing so in a frame it have 2 images or 3 images or 4 images உங்களுக்கு வந்து பாத்தீங்கன்னா ஒரு வருஷத்துல 500 போட்டோ எடுத்தீங்கன்னா உங்களுக்கு 500ஐயும் உங்களுக்கு மெமரியில ஷேர் பண்ணாது சரிங்களா ஏதோ ஒரு 10 இமேஜஸ் தான் அது சூஸ் பண்ணிக்கும் அந்த 10 இமேஜ் எப்படி சூஸ் பண்ணும்னா பிரைட் அண்ட் கிளியர் இமேஜஸ் பிளர் இல்லாம இமேஜஸ் அதுல இருந்து அந்த என்ன பண்ணிக்கும் அந்த 10 இமேஜஸ் சூஸ் பண்ணி so it is giving more otherwise who peoples are liked more images நீங்க ஒரு சோஷியல் ஸ்டேட்டஸ்ல போட்டிருக்கீங்கன்னா so it is automatically read which image got more likes அந்த 10 இமேஜ் மட்டும் தான் அதை எடுத்துக்கும் சரிங்களா so this is the concept that is addition of 2 matrix ஒண்ணு கிடையாது that is so I'm showing the formula so it's come to know for example if I am adding that here gamma value and all the things okay look at here so if I am keeping gamma value equal to 1 so I am getting more bright and more dim all the things blurring effect and everything it come look at here so now if I am increasing the gamma value so I am getting effect in these images okay I am getting the effect in these images okay suppose I am getting the C values going to add okay I am going to C values going to add look at here so this image is going to bright okay this image is going to bright compare look at so this is second image yes or no now it is entirely different initially if I increase the value of that gamma so what getting here all the things I get only the images what first images but if you are combining the alpha beta and gamma 3 values we are getting a 3 different so this technique the Googles or Gemini's or all the generative AIs are using for their purpose okay so what is the max behind this only a simple addition of the matrix அது வேற எந்த ஒரு மேஜிக்குமே நான் அதிகமாக யூஸ் பண்ணல so simple what I am using only the addition of the matrix I used here okay so now we are going for dealing with the subtraction of the matrix இப்போ நம்ம subtraction of the matrix போய் பார்ப்போம் so what how here okay subtraction of the matrix time acha irukla sir 5 minutes okay okay so subtraction of the matrix so I am quickly wind up this one okay subtraction of the matrix okay I am using here for subtraction of the matrix here also I am going to add the images okay I am choosing the more bright image then you come to know yeah look at instead of adding I am going to subtract the values okay what happened that one you look at here darkening shadowing you want to add a shadow or you want to make a dark of the images so that cases you need to use the subtraction that is the C value. Okay, these things only, all your TV remotes and your mobile phone sliders, they are using for increasing the bright and dark. Okay, so the next one we are going for multiplication. Okay, the next one is going for multiplication. So the multiplication, so what happened for if you are using the small multiplication in images? Okay, so I am going to choose this one. So again I am going to choose this image. Okay, look it. Yeah. Okay. So multiplication, whenever if you are using the multiplication, that is called mask. Whenever in a WhatsApp, if you are using all your it is encrypted, decrypted, all the words you are seeing that. Okay. So how it means it is giving a mask. Mask means it automatically adds some Gaussian noise value and it completely blur your image and it gives the output. While again you are replace it, it gives a more clear. Okay. So whenever you are going with element wise calculation, there are in linear, whenever you are dealing with A, you need to think the two things. A dot B is, A cross B is different meaning. That is normal multiplication of two matrix. Okay. Whenever you are dealing with A, this one is very important. The next one very important concept, element wise multiplication, that is array multiplication. So how they are, we are maximizing A dot star B. Yes or no? Discrete math கண்டிப்பா படிச்சிருப்பீங்களே, படிச்சிருப்பீங்க. அதாவது ஒவ்வொரு எலமெண்ட் A11 இருக்கிற A11, B மேட்ரிக்ஸ்ல இருக்கிற B11, அந்த ஒவ்வொரு எலமெண்ட்டும் பார்ப்போம். ஓகே, இது எங்க நம்ம டெய்லி லைஃப்ல யூஸ் ஆகுது அப்படின்னா, உங்க கூகுளோட போட்டோல அந்த கடைசி ஒரு சாய்ஸ் இருக்கு, விண்டேஜ், பார்த்திருக்கீங்களா? அதை அப்படியே கொஞ்சம் இன்க்ரீஸ் பண்ணீங்கன்னா உங்களோட இமேஜ்ல பேக் சைடு எல்லாத்தையும் பிளாக்கா பிளரா மாத்திட்டு உங்க மிடில்ல இருக்கிற போட்டோவை மட்டும் கொஞ்சம் நல்லா என்ஹான்ஸ் பண்ணி கொடுக்கும். பார்த்திருக்கீங்களா? இப்ப வர கேமராஸ்ல போட்டோ, எல்லா போட்டோ எடுக்கிறாங்கல்ல கேமராஸ், அதுல எல்லாத்துலயும் இந்த மாதிரி ஒரு ஆப்ஷன் வச்சிருக்காங்க. ஸோ இட் இஸ் ஃபோக்கஸிங் ஒன்லி ஆன் த ஆப்ஜெக்ட், இட் பிளர் த பேக்ரவுண்ட். இப்போ என்னன்னா பேக்ரவுண்ட் வந்து பிளர் பண்ணிட்டு ஆப்ஜெக்டை மட்டும் ஃபோக்கஸ் பண்ணும். ஸோ தட் பர்பஸ் தே ஆர் யூசிங் த எலமெண்ட் வைஸ் மல்டிப்ளிகேஷன், ஐ மீன் அரே மல்டிப்ளிகேஷன். ஓகேங்களா? ஸோ இட் இஸ் யூசிங் ஃபார் அரே மல்டிப்ளிகேஷன்ஸ் they are using. Okay, so the next one, so we are division we can go. Okay, division we can go. Open images. Yeah, I am dealing with this images. In matrix, we are not talking about A by B. Instead of that, what we are telling? Inverse. Yes or no? So inverse we are talking. So while taking the inverse, what happened? So it is giving more clarity. So what purpose we are using? If adding the value, you are getting the brighten, and subtract the value, it's give the dark. If you are using the division, it giving a shadow of image. It give the shadow of image. At the same time, here also you have the element wise division. So if you are giving the element wise division, so look it here, some shadow images are there. While capturing my images, maybe some shadow is there. Okay, maybe your light shadow. புரியுதுங்களா? நீங்க வந்து போட்டோ எடுக்கும்போது உங்களுக்கு தெரியும் ஷேடோ இல்லைன்ட்டு, பட் உங்களுக்கு தெரியாம ஷேடோ இருக்கும். உங்களுக்கு அந்த ஷேடோவை தான் என்ன சொல்லுவாங்கன்னா நாய்ஸ்னு சொல்லுவாங்க. அந்த ஷேடோ இருந்துச்சுன்னா உங்க போட்டோ கிளாரிட்டியா இருக்காது. கரெக்ட்டுங்களா? ஷேடோ இருக்கா இல்லையான்னு எப்படி ஐடென்டிஃபை பண்ணணும் அப்படின்னா, தென் யூ கேன் யூஸ் த எலமெண்ட் வைஸ் டிவிஷன். ஸோ நாம எலமெண்ட் வைஸ் டிவிஷன் சொல்றோம். நீங்க ஒரு ஏஐ படிச்சீங்கன்னா அது என்ன சொல்லுவாங்கன்னா தே ஆர் ஃபிளாட் ஃபீல்டு. அதுக்கு பேர் என்னங்க? flat field. சரிங்களா? addition of the matrix இருக்குதுல்ல, அதுக்கு வந்து பாத்தீங்கன்னா filter. They are telling about what? Filter. ஃபில்டர்ல வந்து நிறைய படிப்பாங்க, கல்மான் ஃபில்டர் அந்த லாங்குவேஜ். நாம என்ன சொல்றோம், ஜஸ்ட் சேயிங் த அடிஷன் ஆஃப் த மேட்ரிக்ஸ். ஓகே, எலமெண்ட் வைஸ் டிவிஷன் வந்து பாத்தீங்கன்னா தே ஆர் காலிங் த பிளாட் ஃபீல்ட். இப்போ எனக்கு வந்து பிளாட் ஃபீல்ட் இருக்கு இமேஜ்ல, ஐ வாண்ட் டு ரிமூவ் த பிளாட் ஃபீல்ட். ஸோ ஆஃப்டர் கெட்டிங் திஸ் இமேஜஸ் by using the binary image and a prime, I can remove my shadow, and again what I am doing, I restore my original images, then I am getting a perfect image. So this is the A is doing within a fraction of second, because they are using that million of neurons and million of layers, so it is doing that much fast. Okay, so finally that I am only one thing I am with to conclude, that I have more point, but really that I have no time. So for make 3D to 2D, okay, nowadays when I am giving a 2D images, so how it convert to 3D images, so that one is one interesting. So if I am combining all the concept, addition, subtraction, multiplication, okay, in a one frame, okay, in a one frame, I mean ஒரே ஒரு frameல I want to involve all the concept at a time with one output. எனக்கு அந்த one output போகுது அப்படின்னா I can create a, we know only the what, skeleton images. From the skeleton images you can make that 3D images. So these things in forensic department they are using. They want to picture it, identify the postmortem report and all the things. ஏதாச்சும் நமக்கு ஒரு சஸ்பெக்ட் கிடைக்குது அப்படின்னா அந்த சஸ்பெக்ட் பத்தி எதுவுமே தெரியலனா, then we know that something, the body height, weight, all the things, the rough sketch. By using the rough sketch, so we are getting the 3D images. Okay, so இது மட்டும் இல்ல, so that one more things I am using, so you maybe enjoy that one, super Romeos. Okay, you like Transformer, Spider-Man, Aquaman? Yes or no? Same. Without our matrix, nothing there. We let's check with. Okay. So நீங்க வந்து ஒரு அழகா ஒரு கார்ட்டூன் கிரியேட் பண்ணணும், யார் மாதிரி கிரியேட் பண்ணணும் அப்படின்னு பார்த்துட்டீங்கன்னா நீங்க உங்களோட இமேஜவே கொடுங்க, சரிங்களா? ஓகே, I want to measure it. Where is my head? All the things I am going to give that one. Okay, so this is my head top. Okay, this is my head top. Okay, and this is my head chin I am giving. So this is my bottleneck of this one. Okay, so okay, sorry that I am giving a wrong input, so I don't know what getting. Okay, elbow, so it is a measurement. So whenever you are creating the transformer like cartoons, you need to give the measurement. So this is the measurement of my cartoon, all the things you want to give. It is asking now left hip and right hip and all the things. Okay, so left knee, right knee, so this is the measurement of that one. Okay, so there are two purpose they are using. Okay, nowadays in bones technology they are using. Okay, bones technology they are using. So my height is 170 means, okay, I am using. So look it here. So by using this we can create a robotic or whatever the things. These things only before going to create any new cartoons. So we are going to give only a small measurement, and by using all our matrix concept, they are creating this one. You want to move, if it's want to walk or run, all the things, you need to give the sequential input also. Okay, whenever you are giving only the normal image, that is the image. If you are giving image as a sequential input, sequential இருக்கணும், அதே மாதிரி இமேஜோட இருக்கணும் அப்படின்னா that is video. You want to make this man as moving or walking or that dancing and all the things. So that cases you need to give a sequential input. சரிங்களா? Image sequential input கொடுக்கணும். So if you're giving, so you are getting this type of robotic animes. சரிங்களா? Okay. So only the two things. We are always dealing with matrix and all the things, but we don't know. Okay. Just you think about it. You don't think about that images and all the things as a matrix. Okay, whenever if you are uploading images or whenever if you are uploading whatever the thing, why, what max behind that? அதுக்கு பின்னாடி என்ன மேக்ஸ் இருக்கு அப்படிங்கிறது ஜஸ்ட் இஃப் யூ ஆர் திங்கிங் தென் டெஃபினெட்லி யூ ஆர் மாஸ்டர் இன் ஏஐ. உங்களுக்கு கண்டிப்பா வந்து பாத்தீங்கன்னா என்ன ஆகலாம், நீங்களும் ஒரு மாஸ்டர் இன் ஏஐ மாறலாம். Then more AI labs are here for creating the more job vacancies, then definitely you can apply it. For example, that Microsoft is opened AI lab here, Google is opened AI lab here, and already CSAR is already opened a image processing lab here. So if you are knowing something about the image processing and all the things, math work. So that is MATLAB we are using. The head is in USA, so math work. So in India, the hub is here in Bangalore. So small techniques. That's all. You don't think about only the matrix. You just think about flip it. So what is the name in other languages? Just now it is the platform is yours. In your hand you have the AI. So for writing assignment or writing case study, you just ask him. So what is the max behind any images? So how you are getting the prompt to solution? What max behind that? You ask that. Okay. Otherwise, if you want to know about the AI mathematics, you ask. You give that one small that course for me. Daily you teach me. You go regularly. That you update yourself. Definitely, you also master in AI. Thank you, all of us. Thank you for giving me. Thank you for HOD ma'am, all the department faculties and all the students, participants from outside, abroad, then particularly that Hariharan sir and one more sir, Subramanian sir, make my travel smooth and all the things. So thank you for giving this wonderful opportunity. Thank you. I think you maybe enjoy, right? கவனிச்சனே நிறைய பேர் மொபைல் வச்சு தான் தலையை குமிச்சிட்டு இருந்தீங்க அந்த கடைசி எல்லாம்.
If you have any questions, you can ask.
Sir, you said that computer knows only red, green and blue colors. நம்ம எப்படி சார் ஒயிட் கலர் எப்படி சார் கிரியேட் பண்ணுவோம்?
000.
சார் நம்ம ஒன்னு வெக்டார் பண்ணும்போது நமக்கு வந்து கிரே ஆயிடுது சார், எல்லாமே 0 பண்ணா ஒயிட் ஆயிடும். நீங்க வந்து
ஒரு கலரை மட்டும் நீங்க விட்டுட்டீங்கன்னா ரிமைனிங் 2 காம்பினேஷன் எடுத்துக்கும். சரிங்களா? இப்போ அந்த 2 அதாவது E1100 010 001 கரெக்ட்டுங்களா? அந்த ஏதோ ஒண்ணுல வந்து பாத்தீங்கன்னா நீங்க 0, அதாவது E100 இருக்குல்ல, அதை 000 எடுத்துட்டீங்கன்னா கிரே கலரா கொடுத்துரும். இப்போ யூ வாண்ட் கம்ப்ளீட் ஒயிட். இப்போ நீங்க கம்ப்ளீட் ஒயிட்னா 000 கொடுத்துட்டீங்கன்னா அது கம்ப்ளீட் ஒயிட்டா இருக்கும். 128 கொடுத்துட்டீங்க அப்படின்னா தட் இஸ் கிரேவா இருக்கும். 255 கொடுத்துட்டீங்கன்னா பிளாக்கா மாறிடும். Doubt? Thank you.
Thank you, sir, for the insightful presentation. Your discussion on the intersection of linear algebra with AI is a vital contribution to the field of mathematical modeling. Actually, our students have studied the linear algebra as an abstract, but now you have linked that with AI, and I hope they are very much benefited by your lecture. Thank you very much, sir. As a concluding session of the inaugural session, it's my privilege to propose the formal vote of thanks. Gratitude is the inward feeling of kindness received. Thankfulness is the nature impulse to express that feeling. It's my privilege to propose the vote of thanks and acknowledge the efforts of everyone who worked diligently to make this event a success. First and foremost, I express my sincere gratitude to the Almighty for making today's event a resounding success. I extend my heartfelt thanks to our Secretary, Dr. Ashok Kumar Muntra, for his constant guidance and encouragement. I express my special and profound gratitude to our esteemed Principal, Dr. S. Santosh Babu, for visionary leadership, unwavering support, and continuous motivation, which have been instrumental in organizing this conference successfully. His encouragement and belief in our initiatives always inspire us to strive for excellence. I also place on record our sincere appreciation to Professor M. Devika, Head Department of Mathematics, for her dedicated efforts, guidance, and support in coordinating this event. My deep appreciation goes to all our dedicated faculty members for their untiring efforts. I sincerely thank the organizing team for of their dedicated efforts in organizing this conference. I also thank all the volunteers and students for their wholehearted cooperation and support. Finally, I extend my gratitude to all the participants and paper presenters for being part of this conference. My sincere thanks to Visual Communication Department for arranging the photography and videography, and to the data center for providing the live YouTube links streaming support. Thank you all once again. Thank you, sir. It's now it's a tea break. You can have your tea outside. Next session will commence at 10:45. 10 minutes. 10:50. You have to assemble here itself, right? So it will start exactly at 10:50. So 10 minutes break. So assemble fast.
மீட்டிங் வருவாங்களா அப்டேட் கொடுத்து உட்கார்ற மாதிரி தான் இம்பார்ட்டன்ட் தான். யாரு தெளிவுலாம் வந்து அலுமை தான் அடிக்குது. ஸ்வேதா ஆமா ஆமா அப்படியே டீ குடிக்க மாட்டேன். எப்படியோ நான் டீ குடிக்க மாட்டேன். பார்த்தா சொல்லுங்க இருக்காங்க. அவர் பேசின்னு இருக்காரு இந்த ஸ்கிரீனை பிரசன்ட் பண்ணிட்டு இல்ல நம்ம வீடியோ ரன் பண்ணிடலாம்.
இந்த மாதிரி டைப்ல தான் தோத்து வருது.
நான் யூஸ் பண்ணடி நான் கை இருக்கு பாக்குறது தான் பாரு ஐயோ அட்மிட் பண்ணிட்டே இருந்துச்சு சார். ஒரு 2 நிமிஷம் போனதுக்கு அப்புறம் கேட்கிறேன். சரி நீ போயிட்டு வா. நான் இப்ப சங்கீதா பிரசன்ட் பண்றாங்களாடி? எந்த சங்கீதாடி? நம்ம சங்கீதா சார் 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 டீ டீ பிரேக் போயிட்டு வரலாமா? இது சார் சரி
வெயிட் பண்ணுங்க.
சார் ஸ்டூடெண்ட்ஸ் ப்ரெசன்டேஷன் எந்த இடத்துல நடக்குது?
ஏய் இவனுக்கும் சாப்பிடாதுமா பின்னாடி நோட் பண்ணிட்டு இருப்பாங்க மாட்டுக்கு வேணாம் திட்டுவாங்க இது வந்து அண்டர் த கண்ட்ரோல் ஆஃப் மேல வந்து வெளில போய் சாப்பிடுறது வெளியே போய் சாப்பிடு பார்த்துட்டு இருப்பாங்க கீழே அதை அங்கேயே வச்சிருப்பாங்க. இங்கே நெட் வந்துருக்க மாட்டாங்க. ஆமா ஆமா. இல்ல 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 பசங்க இப்பதான் வெளியில பேட்டரி வாங்க போட்டிருக்காங்க. ஏன்னா இந்த மைக் கிடையாதுல்ல, காலர் மைக்ல வேணும். அந்த மைக் இந்த மாத்திட்டு இருக்க மாட்டாங்க. காலர் மைக்கு பேட்டரி வேணுமா இந்த பசங்க அனுப்பிட்டு பேசிட்டு இருங்க. டிவிஏ பேட்டரி இல்ல 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 இல்ல. நானே கால் பண்றேன் திருப்பி பேசிட்டு இருங்க இருக்கேன்.
அவங்களாம் அடிங்க சார் அவனை. சார் எதோ போயிட்டானுங்க ஓடி. பிரபகரி செக்ரட்டரி லோகேஷ் சார் இவரு கவனில ஒரு ஐஐடி வந்து சரி யூஸ்ஃபுல்லா பெரிய அளவு பாதி பண்ணி ஒன்னு வரும். நீ வீட்டுக்கு போயிட்டோம் வேற என்ன சார் வேற இங்க மட்டும் தான் செகண்ட் இயர் அது இது ஆன்லைன் இது அங்க ஆன்லைன் இது இது வந்து ஆஃப்லைனா அங்க ஆன்லைன் ஒரே டைம் ஆன்லைனா வேற ஓகே வேற வேற ரிசல்ட் வா மீனா எங்க போயிரோம் உட்கார் இங்க உட்கார் சரண்யா பொண்ணு காலைல இருந்து வரையில உங்க உட்காருங்க இங்க உட்காருங்க முன்னாடி உட்காராங்க போகணும் சொன்ன அப்புறம் ஆளே கிடையாது வாய்ப்பே கிடையாது முடியாது. நீங்க மத்தவங்க பத்தி காலி எவ்வளவு நேரம் டீ பிரேக் வந்து உட்காந்து சீக்கிரம் போயிட்டு இந்த பக்கம் வா வித்யாவதி இந்த பக்கம் ஃபர்ஸ்ட் ஒன் நீங்க அப்படியே முன்ன வாங்க பின்னால உட்காராதீங்க
மேல உட்கார பண்ணுவோம். இந்த லாஸ்ட் இருக்கிற மொத்த பேர் பண்ணுவோம். முன்னாடி பேக் வச்சுக்கணும். மகேஷ் என்ன பேர்? லாஸ்ட்ல உட்காராதுன்னு சொன்னேன். மொத்த பேர் முன்னும் வாங்கி இடம் இல்லை. அங்க இங்க ஃப்ரீயா இருக்குவா. லாஸ்ட்ல உட்காராது. ஏறு ஃப்ரண்ட்ல வாங்க சீக்கிரம். முன்ன முன்ன லாஸ்ட்ல உட்காராது. ஃப்ரண்ட் அங்க எங்கேயுமே உட்காராதீங்க. ஃப்ரீயா இருக்கு வாங்க. இங்க வாங்க இங்க வா. ஃப்ரீயா இருக்கு. முன்ன 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 வா இங்க வந்து உட்காரு. ஒண்ணு கேட்க மாட்டேன். முன்னாடி உட்காருங்க. ஃப்ரண்ட் அப்படியே ஃப்ரண்ட் இங்க இருக்கா? உட்காரு. எங்க போயிடா? இப்பதான் வரையா? இல்ல லாஸ்ட்ல போவாத. ஃப்ரண்ட் லாஸ்ட்ல யாருமே உட்கார கூடாது. அந்த ஒரு லைன் உட்கார கூடாது. வா இங்க ஃப்ரீயா இருக்கு. டேய் இங்க வந்து உட்காரு. லாஸ்ட்ல உட்கார. அரவிந்த் எழுந்து வா. இங்க வா. காலசி இங்க செயின் மேல ஒரு ஷர்ட் மேல ஒரு செயின். ஐடி கார்டுக்கு மேல ஒரு செயின். ஒரு பட்டன் காட்டிக்கோ. ஏய் தனி பாலம் எங்கடா? இன்னும் வரல. அவன் தானே எடுத்து கிராஜுவேஷன் எங்க குரூப் மெசேஜ் ரிப்ளை பண்ணிடுங்க. பாத்தீங்களா இல்லையா? பிக் போட்டுச்சு நமக்கு. இப்ப போட்ட மெசேஜ் போட்டா பாத்துட்டு ஏய் அவன் போன் பண்ணுங்க. டைம் கரெக்டா சொல்லிருக்கான். நான் 7 மணி 9 மணிக்கு நான் வெளியே சீட் எடுத்து கிளாஸ்ல மொத்தமா 7 பேர் தான். 7 பேர் வந்து வாய்ஸ் 7 மணி அவன் போட்டாரு. 7 மணிக்கு மேல யாரும் வந்து அது மேல வந்து லேட்டா வரீங்க. இன்னும் கிராஜுவேஷன் மாறல. சீக்கிரம் வரணும். கரெக்டா வந்துருங்க. அதுல யாரு கேட்டாலும் சொல்லிடு. அவன் ஆகாஷ் தான் ஒரு சும்மா உட்காந்து படிக்க மாட்டான். இது பேப்பர் பர்சன்டேஜ்
டேய் டேய் எக்ஸ்ட்ரா கரிக்குலர் ஆக்டிவிட்டிலாம் பண்ணாத ஐஐடி ப்ரொஃபஸர் வர்றாரு அமைதியா ஐஐடி ப்ரொஃபஸர் வர்றாரு டிசிப்ளினா இருக்கு ப்ரொஃபஸர் வந்து ஹாய் சார் வாங்க
Morning, sir. We begin our next session. I invite Professor K.C. Sivakumar, sir, Professor, Department of Mathematics, Indian Institute of Technology, Madras. A token of appreciation, I invite Professor Devika, Head Department of Mathematics, to felicitate Dr. K.C. Sivakumar, sir, with shawl and moment. Okay, sir. A great honor and privilege to introduce our distinguished speaker, Dr. K.C. Sivakumar, Professor, Department of Mathematics at Indian Institute of Technology. Dr. Sivakumar completed his PhD from IIT Madras, specializing in functional analysis. Over the years, he has established himself as a leading researcher in areas such as operator theory, mathematical programming, generalized inverse of matrices and operators, and linear complementary properties. His research work has been widely published in reputed national and international journals, contributing significantly to the advancement of mathematical sciences. An inspiring teacher and dedicated mentor, Dr. Sivakumar has successfully guided several PhD scholars and postgraduate students. His commitment to academic excellence and clarity in teaching earned him the Best Teacher Award for Excellence in Teaching in 2024 from the Department of Mathematics at IIT Madras. Beyond classroom teaching and research supervision, Dr. Sivakumar has made valuable contributions to national academic initiatives. He has delivered courses under the prestigious National Program on Technology, Enhanced Learning, NPTE, benefiting thousands of learners across the country through online education. He has also served as a resource person for UGC HRDC refresher courses, sharing his expertise with faculty members from various institutions and contributing to higher education development at the national level. Dr. Sivakumar is widely respected for his depth knowledge, academic integrity, and passion for mathematics. His work reflects a rare blend of rigorous theory, effective pedagogy, and commitment to academic services. Today, we are truly privileged to have such an eminent scholar with us. On behalf of the organizing committee, I extend a warm and heartfelt welcome to Dr. K.C. Sivakumar. We are honored by your presence.
This whole screen will complete. No, yeah. Um, That's okay. It is not particular. I thought I'll use as a standby. It's okay. Okay, let me start off without much delay. So this topic of my talk. Pinadi bench la kaadu varudha. Okay. So the topic of my talk is matrix theory. Okay. And matrix theory is absolutely important. In the age of artificial intelligence, machine learning, etc., you better learn the basics of matrix theory. Okay. So I believe in the earlier talk there was some mention about singular value decomposition, minimum rank approximation, some linear regression, etc. All that is matrix theory. So this talk will also be matrix theory. Okay. And the problem, see, in matrix theory, research problems are easy to pose. Problems are easy to pose, but difficult to solve, just like number theory. So I'll give a quick introduction to the problem, basic problem. What is the question that we posed based on the basic problem, and what is the answer, solution to that problem? Okay, so there are some MSc students here, first year, second year MSc students. Can you raise hands? Ah, that's a lot. So how many of you have written GATE or CSIR exams? February, you must have had GATE exam, right? So February first week, second week, you wrote. Okay. CSIR, how many? Nobody. UGC CSIR. Are you at least aware of it? Have you heard of it? Kellypatrakingla. Okay. So that's like an entrance exam to IITs, NITs, etc. When you write a GATE UGC CSIR exam, if you clear the exam and you join an institute, you will get fellowship. Okay, the fellowship is quite attractive, something like 35,000 rupees per month. So you can earn as well as study. So you can justify to your parents that you are earning, right? It's almost like a job, and you can also do research. That is up to 5 years you will get the fellowship. Okay? We all came through such programs. And you can join institutes like NITs, IIT, because and you know, the moment you come out of those institutions with a PhD or MSc, BSc final year students, how many are here? Yeah, so have you heard of JAM exam? How many wrote JAM exam? Only one. Okay. The JAM is joint admission to MSc programs for all sciences. Physics, chemistry, math, and biology, biotech in IITs. And the JAM exam is for MSc. The moment you finish your MSc, it will be a turning point in your life. Okay, so these exams, for these exams you have to prepare, you have to work hard. See, to achieve anything in life, you have to work hard. Okay, so you have to work hard and then clear these exams, join for MSc programs. The moment you finish MSc, you will get very good jobs. And any degree from IIT is a turning point in life. Okay, so many are first generation learners, and so you should contribute to your family. You contribute to your family, the standard of living gets better. That's a contribution that you do for yourself. That's a contribution to the country. Okay. Suyanalamla podunalam. Podunalamla suyanalam. You understand, right? Okay. In the light of so this is the topic. So you should try writing JAM, exam, GATE, CSIR, UGC, etc. and join IIT Madras. I want to see some of you next year in my department. And 20 years down the line, some of you should be giving talks like how I am giving talk here. So at least one or two of you should come back to DG Vaishnav College and come as invited speakers from some institutes, some big institutes, and give talks. That's like a contribution to the community, mathematics community. It's like paying back to your teachers. Okay, so this is the topic. I'll try to make the presentation as simple as possible. So there are some terms here. No? You know what matrices are. A matrix is an array of numbers. Tridiagonal, if you have not seen, this is the first time, I'll explain what it is. Inverse, matrix inverse. We all know about matrix inverses. Remote, you have to operate. Okay, next one. Yeah, so this is the plan. Okay, there's an introduction or a quick motivation as to why this problem is important. And then some special properties, then inverses of tridiagonal matrices, triangle property matrices, and so these three are the main topics. So even if you remember these words after today, when you go back home, then when you remember, you will think about what those things are, etc. By the way, mathematics is not like watching a movie, you will just forget it immediately. Mathematics needs to be worked on the paper, pen and paper, math. Still, no amount of watching someone talking mathematics will help you understand mathematics. It will give an exposure. இந்த மாதிரி டாபிக்ஸ்லாம் இருக்கு, that's the exposure. But for you to understand, you have to work. Okay, mathematics அந்த மாதிரி. It's not like watching news or something, then you will know who is the president of which country or etc. Mathematics you have to practice, you have to work. Okay, and reduce your dependence on ChatGPT for solving problems. Yeah, ChatGPT can give you wrong answers. Lots and lots of wrong answers. So ChatGPT wrong answers கொடுக்கிறதுன்னு உங்களுக்கு தெரியணும் அப்படின்னா you need to be one step ahead. Okay. So you be clear about it. ChatGPT is not God. It does lots of mistakes. 3x3 matrix inverse ChatGPT cannot compute correctly. 3x3 matrix inverse, which you can do yourself using elementary row operations. Okay, so you have to be careful using ChatGPT. ChatGPT is not Vedavak. So be clear about that. You need to verify the answer from ChatGPT. So if you can go with these three things today, there is some tridiagonality notion, there is some triangle property notion, and there is some inverse matrix. If you go with these three notions, then I think I would have served the purpose for today's talk. So this is the plan. Okay, next. So what is tridiagonal? Tridiagonal means that's the precise definition. Okay, any definition in mathematics is a precise one. But informally, what it says is that non-zero entries of the matrix will lie only on the main diagonal. It's called principal diagonal, super diagonal, and subdiagonal. Adanala, it's called three diagonals: principal diagonal, super diagonal, subdiagonal. Non-zero entries appear only in these three diagonals. Such a matrix is called a tridiagonal matrix. You know what a diagonal matrix is? Principal diagonal mattum non-zero entries irukum. That's called a diagonal matrix. Tri means three. Mono. So TRI is 3 and 3 is the principal and super. Principal, super diagonal, subdiagonal. And the mono diagonals you have non-zero entries. The rest of the entries are zero. The rest of the entries of the matrix are zero. Such a matrix is called a tridiagonal matrix. So this is the precise definition. Entries of a matrix A are denoted by Aij. Appo Aij must be 0 when absolute I minus j is greater than 1. Abdina, what about A24 for example? 0 va liya. A24 must be 0. Okay, but A24 ngiradhu enga irukku? Second row, fourth column. Second row, third column may not be 0, but second row, fourth column has to be 0. Second row, fifth column has to be 0, etc. Okay, so that's the idea. So this is the structure. This is called a structure thing for a matrix. Structure property. Diagonal, tridiagonal, pentadiagonal, Hessenberg, and Murray. There is a lot of structure for matrices. So this is structure. Okay, see the next one. This is an example. This is how it looks like. See, these entries here and here are 0. மற்ற என்ட்ரிஸ் பற்றி தெரியாது எனக்கு, பட் zeros are beyond these three diagonals, all other entries are zero. Okay, that much I know. Some of these entries also can be zero, but that's a different matter. Okay, next one. Idilave some special classes irukku. There is a matrix class called Toeplitz matrix. Toeplitz matrix, when these diagonal entries are the same, these diagonal entries are the same, these diagonal entries are the same. Other than definition. So next slide will give you a Toeplitz matrix. Next one. Yeah. So this is a Toeplitz matrix. Main diagonal, that's called principal diagonal. Principal diagonal entries ellame constant. Super diagonal entries ellame constant. Subdiagonal entries ellame constant. All of these can be equal also. Okay. But the mari matrices arise in a lot of applications. That is why these are important. Okay, Toeplitz matrix. Toeplitz matrix, you know what an eigenvalue is, right? See, eigenvalue, can someone give a definition? Eigenvalue for matrix A. Just a definition. A number lambda is called an eigenvalue of a matrix A if some condition, in a condition. Ax equals lambda x, apro? Ax equal to lambda x for any number lambda is satisfied by x equal to 0. Apo, there is no condition on lambda. Ax equals lambda x is satisfied by any number lambda if you take x equal to 0. Apo. See, it's also called characteristic value. Abdina, there is some character of the matrix that's being carried by the eigenvalue. Apo, illa number eigenvalue what is there is nothing, no characteristic, no character of the matrix A that's being carried by that number. So, what is the revised correct definition? A number lambda is said to be an eigenvalue of a matrix A if there is a non-zero vector x such that Ax equals lambda x. Zero vector x. Apo, you push this to the right hand side, you have Ax minus lambda x equal to 0. You can write it as A minus lambda times x equal to 0. Homogeneous equation, non-zero solution. X non-zero. Homogeneous equation, non-zero solution, when will it occur? Homogeneous equation non-zero solution எப்போ இருக்கும்? Square system. I have a homogeneous equation Bx equal to 0. Capital B is a matrix, x is a column vector equal to 0. I want a non-zero solution for Bx equals 0. அது எப்போ ஆகும்? I want a non-zero x such that Bx equals 0. It will happen if and only if B is 0, தப்பு. Determinant of B is 0. B 0 இருக்கணும் அவசியம் இல்லை. B0 are, see, that is why you need to be careful with matrix multiplication. You know what an integral domain is, no? You know what a ring is, you know what an integral domain is. AB equal to 0 implies, with A not equal to 0 implies B equal to 0. AB equal to 0 implies either A is 0 or B is 0. Those are called zero divisors, right? So, matrix multiplication, you can have the product to be 0 without either of the factors being 0. So B0 determinant of B is 0. Okay, that is the definition of determinant of B equal to 0 is the definition of an eigenvalue. Now, why is an eigenvalue important? Eigenvalue is important for the following reason. See, matrix equation models physical phenomena. Okay, there is a physical problem, engineering problem. And the matrix equations model the physical phenomenon. And the physical phenomenon, for example, there is a bridge. The bridge consists of, let's say, 10,000 springs. See, a bridge is something that moves up and down, and that's because of springs. Springs and iron rods which can move. There are some springs, and the spring order eigenvalues n. I need to know because and the springs or eigenvalues determine the moment of the bridge. If the eigenvalue, that value goes beyond some limit, then the bridge will collapse. So I need to know how to control the bridge from collapsing. So I need to know the eigenvalues. That's the physical application. Okay, many of you have used Google's algorithm, right? Google search. You have used Google search. Google search, you get the answer based on an eigenvalue equation, eigenvalue eigenvector equation. The only thing is that matrix A is of order some 10 million by 10 million something, and you get those pages. So it is computing an eigenvector corresponding to an eigenvalue. Google's PageRank algorithm is that. So there are lots of physical applications, lots of applications coming from real life, which can be modeled as eigenvalues. அதனால eigenvalues என்ன அப்படின்னு தெரியறது for a matrix is important. So the eigenvalues of a Toeplitz matrix are these. In general, computing the eigenvalues is a difficult problem. நம்ம கிளாஸ் ரூம்ல போடுறது 3x3 matrices. அதுக்கு கூட கொஞ்சம் entries கொஞ்சம் modify பண்ணா it will be difficult to calculate. In the class, the matrices that you encounter in real life are all huge orders. 10 million, 20 million, 30 million, several crores. Matrices are, they are entered as bits through a channel. Okay, a cricket match is being telecast live and there is something that goes through a channel. You can't push all the bytes through in one instance. So you pick only a few of the bytes and then send them across the channel. There is image compression, etc. So on the you need to find not all the eigenvalues, but just the first few eigenvalues. So eigenvalues are important in many applications. It's difficult to compute eigenvalues of matrices, but there are some matrices for which eigenvalues formula can be given at once. This is one such instance. Okay, so in general it's difficult. It's available in some very special instances. This is one instance. So when it comes, you take it because it's useful. Next one. Why are tridiagonal matrices important? How do you see? You have learned numerical methods of solving differential equations. Numerical methods for solving differential equations. Okay, d square by dx square plus dy by dx plus y equals e to the x. There is some you need two conditions, initial conditions or initial boundary conditions, etc. These equations are easy to solve. When the right hand side is exponential badala, you give some other function, the delta function. Then you have to solve them numerically. Numerical solution of differential equation, what is the idea? The idea is to replace the derivatives by difference coefficients. The idea is to replace the derivatives by difference coefficients. When you replace that by difference coefficients, then you solve a matrix equation. Okay, so here is one example. Is a heat equation. Is a one-dimensional heat equation. T is a time variable, x is a space variable, one-dimensional heat equation. This can be reduced. Central differences. Yeah, you will get this equation. This equation is what you need to solve. This left-hand side is known. This matrix is given. Delta x is the step size. This right-hand side u1, u2, etc., un, that is known. You have to solve this equation. I'm sorry, this is known. You have to solve for u1, u2, etc., un. So in the equation you have to solve in order to solve the differential equation by numerical methods. In the matrix is tridiagonal. So this is one place where tridiagonal matrices come. Tridiagonal matrices come in many places. This is just one example. Okay, why should we study tridiagonal matrices? This is one situation. Yeah, next one. Tridiagonal matrix. See, if you see in mathematics, when you are given a problem, I'll give you a problem. Maximize x square plus y square subject to x plus y equals 1. You want to write it down? Maximize x square plus y square subject to x plus y equals 1. Maximize x square plus y square subject to x plus y equals 1. Can someone, you don't have to solve, but what kind of a problem? Have you seen this problem before in some situation? இது எப்படி solve பண்ணிக்க? See, this is an example of what is called as an equality constrained extremization problem. How many of you have heard of Lagrange multipliers? Nobody? Hey, come on. Lagrange multiplier method. First semester. Several variable calculus you learn that. Conditional extremization. Maximize x square plus y square subject to x plus y equals 1. Can you solve this problem geometrically? சொல்லுங்களேன் யாராவது. Maximize x square plus y square subject to x plus y equals 1. Okay, see in the problem, given the problem, you should not start, see if you, this problem can be solved by what is called as Lagrange multipliers method. This problem can be even more easily solved by geometric idea. Plot x plus y equals 1, right? X plus y equals 1 is something that passes through 1, 0, 0, 1. That's a straight line, infinite straight line. You plot x square plus y square equal to 1 by 2, x square plus y square equal to 1 by 4, 3 by 4, etc. And then slide that circle. Where does it meet the line? At all those points, you compute the value of x square plus y square. Among those points, pick the minimum one. This is a geometric way of solving this problem. Okay, but if you look at the problem carefully, so the Lagrange multipliers to solve pannalam. You form the Lagrangian x square plus y square plus lambda into x plus y minus 1. Derivative 0, and then you get the stationary points. But you can solve this problem by observing that if you interchange the roles of x and y, x ku badala y, y ku badala x, if you do that, you get the same problem. Maximize x square plus y square, interchange x and y, maximize y square plus x square. Subject to x plus y equals 1, interchange x and y plus x equals 1. Same problem. So it is symmetric with respect to x and y. Adanal enna? Can someone exploit that idea? You can take x equal to y. You can take x equal to y. So if you take x equal to y, you need to maximize 2x square subject to 2x equals 1. X equal to 1 by 2, that's a solution. This problem reduces to one variable calculus. One variable calculus, derivative 0, second derivative positive, negative. That's what you have to see. So given a problem, you just don't solve in mathematics, you need to solve it efficiently. You need to solve it efficiently. Brute force use panni prayojanam illa. Brute force use panna, there is no need for math. You need to solve problems efficiently. So given a problem, you need to look at the structure. Is there some structure? Is there some information that I can exploit? Tridiagonal matrix has a structure which I want to exploit. Tridiagonal matrix structure is what I want to exploit. So if you solve Ax equal to B by some MATLAB process, it will take more time if you don't use a special solver. So there is a tridiagonal matrix algorithm in MATLAB. If you use a tridiagonal matrix algorithm, then the amount of time that takes is order of n. If you do a general purpose algorithm, it is order n cube. Order n cube means that when n is large, n cube is much larger than n. So it takes much more time if you use a general purpose algorithm to solve an equation. If you use a tridiagonal matrix algorithm, it takes much lesser time. So you need to look at the structure. The problem of the structure and how to exploit. That is part of math. Ide madri, I'll skip this. Ide madri eigenvalues. General purpose algorithms for eigenvalues, next one, and the next one. Yeah, general purpose algorithm for eigenvalues order n square. But if you do a tridiagonal matrix algorithm, eigenvalues compute pandrathu is order of n log n, much less time. So it helps to look at structure and exploit it in your method of solving. In the method of solving, you can exploit the structure. That's the idea. The structure that we have is tridiagonal. Okay, next one. Or tridiagonal matrix, if it is non-singular and irreducible, forget irreducibility. I'll explain that later. You can associate a graph to a matrix. If the graph is connected, then the matrix is said to be irreducible. There is a strong connection between matrices and graphs associated with matrices. You can understand one from the other one. If you want to understand the matrix, you can sometimes look at the graph corresponding to the matrix. If you want to understand the graph, look at the matrix corresponding to the graph and you can infer some information. So if a matrix A is non-singular tridiagonal, then the inverse is given in terms of purely 4 vectors, u, v, x and y. If a matrix is tridiagonal and non-singular and irreducible, then the inverse is given by 4 vectors x, y, u, v in this manner. So formula for the inverse is this. You can compute the inverse easily. This is one instance. What instance? Tridiagonal. If the matrix is tridiagonal, then the inverse can be given in terms of 4 vectors u, v, x and y, and the entries of the inverse are known. These are called Green's matrices. Yeah. Next one. Next. Yeah. So triangle property. So tridiagonality one paathom. Tridiagonality is a structure. Triangle property is property on the entries of the matrix. Property on the entries of the matrix. So in the property is called triangle property. Aij equals Aik, Akj by Akk. This is the property that must be satisfied. Next one. Whenever I, j, k are indices that are related in this manner, k lies between I and j strictly. If the index k lies between I and j strictly in this manner, I less than j, k less than j, or I greater than k greater than j. For all such tuples I, j, k, the property must be satisfied. If that happens, you say that the matrix A has triangle property. This is a property on the entries of the matrix. This is a property on the entries of the matrix. What we saw earlier was a structure of the matrix, which is tridiagonality. Okay, how are these two related? I'll give an example. Yeah, you can verify that this matrix satisfies a triangle property. Okay, for example, let's look at A24. A24 is, what is A24? 2. Second row, fourth entry, that is 2. Is A24 the same as A23 into A34 by A33? Calculate panna solunga. That is the property here, right? So I is 2 in this example. So I'm asking you to calculate A24. I is 2, J is 4, K is 3. So compute A23 into A34 by A33. Do you get 2? Yeah, so that property is satisfied. You should verify this for all such tuples I, j, k. So you can verify that this matrix has a triangle property. This is an example. There are many such examples. I have included in the next one. Yeah, these are matrices that possess the triangle property. You can just write down one of these matrices. Go home, verify. The first one, minimum ij. Aij equals minimum I comma j. Now you take a matrix A of order 4, and then A11, A12, A13, etc. Now first row entries line minimum ij. First row entries enna. First row entries are 1. Second row entries are 2, etc. Not exactly 2. Left entry is 1. The rest of the entries from the diagonal are 2. So you can calculate this. The first, so just pick the first one, verify that it has a triangle property. I'll leave that for you. And verify for 3 indices I, j, k, you need to verify that whenever k lies between I and j, Aij equals Aik into Akj by Akk. Okay, so these are some examples of matrices having the triangle property, apart from the first example that I gave in the previous slide. Okay, next. Triangle property is one property on the entries of the matrix. Tridiagonality is a property on the structure, but these two are connected. That connection is given by this theorem. Yeah. Let A be a non-singular matrix. Next one. In the condition, diagonal entries except the first one and the last one are required to be non-zero. Yeah. Then A has triangle property if and only if A inverse is tridiagonal. This is that property. So this is a relationship between a property given in terms of the entries of a matrix and a property that comes by virtue of how the matrix looks like, structure. how does it look like? That is related to entries having some property. Okay, so these are so when you have two different concepts being related by a theorem, that theorem is interesting and it will have applications. So this problem has lots of applications, but this is the main theorem. So you can go, if you go with this theorem for today, it is done. That serves the purpose of my lecture. A has triangle property if and only A inverse is tridiagonal. Okay, one example. Yeah, so this is the matrix A. You can this is different from the one that I showed earlier. This matrix has triangle property. Its inverse, you can see, next one, is a tridiagonal matrix. Just for illustration. One example to illustrate the theorem. Okay, A has triangle property, diagonal entry is some condition, A is invertible, then A inverse must be a tridiagonal matrix. Okay, yeah, next one. So after this, what do you do? I'll not go to any of the slides after this. I'll just discuss now. This is one problem that has been solved, okay, long ago, 50 years ago. This problem has been solved. This theorem was proved some 50 years ago, 1978. From this problem, what are the new problems that one can solve? I told you that you can associate a graph to a matrix. You can associate a graph to a matrix. How many know that? How many have seen how to associate a graph to a matrix? Not many. Okay. You take a matrix whose entries are Aij. The order is n cross n square matrix. I want to associate a graph. And the graph has n vertices. How is the graph defined? Through the matrix. Okay, the graph has n vertices. Between vertex V1 and vertex Vi and Vj, I draw an edge if Aij or Aji is not 0. This is how I draw the graph. Okay, given a matrix, I draw a graph. You know what a graph is, right? A graph has set of vertices, set of edges. Set of vertices, set of edges. The number of vertices for a graph corresponding to a matrix of order n is n. So there are n vertices if you start with an n cross n matrix. So I can associate a graph corresponding to a matrix. The vertices are denoted by V1, V2, etc., Vn. I draw an edge between V1 and V2, for example, if either A12 or A21 is not 0. A12 or A21 is non-zero. I draw an edge between V1 and V2. This is how I draw the graph fully now. What is a graph corresponding to a tridiagonal matrix? Apo. What is a graph corresponding to a tridiagonal matrix? Okay, can you just go to the previous one? Okay, in the graph, in the matrix, you draw a graph. Okay, so how many vertices are there? 4 vertices. Okay, draw on your sheet. You draw 4 vertices. Okay, in any order that you want. Or straight line la V1, V2, V3, V4. Okay, draw those little circles. Okay, now you complete the graph. Between V1 and V2, is there an edge? V1 ko V2 ko, can I put an edge? Yes, because A12 is non-zero in the graph, in the matrix. A12 is not 0. So between V1 V2 there is an edge. Between V2 V3, again I can put an edge because V23 is not 0. Adhe mari V34 there is an edge. And so on 4 vertices, I draw a graph. It's called a path. It's called a path on 4 vertices. 1 to 2, 2 to 3, 3 to 4. 3 edges, 4 vertices. It's called P4, path on 4 vertices. This is a graph on the graph corresponding to this matrix is P4, path on 4 vertices. A path is an example of what is called as a tree. A path is an example of a tree. What is a tree? A connected acyclic graph is called a tree. A path is an example of a tree. Suppose I had one more in the entry non-zero are now. first column, last row, and the entry non-zero nanna, it is A41, right? A41 na, from 4 to 1 you have an edge, it's a cycle. It's an example of what is called as a simple cycle. This is a simple cycle. Okay, so you can convert the problem into a graph theory problem. When the matrix A has triangle property, then the graph corresponding to the inverse is a path. When the matrix A has triangle property, then the graph corresponding to A, corresponding to the inverse, is a path. If the graph corresponding to the inverse is a cycle, simple cycle, what must be the property that A has to satisfy? Triangle property or property. What property must A satisfy in order for the inverse to have the property that the graph corresponding to the inverse is a simple cycle? This is a simple problem that I have posed, but it's difficult to solve. This is a difficult problem to solve. And the matrix A, what must be the property that must be satisfied? So this is a kind of a research question that you can keep asking. Another question. Suppose all the entries of the last row are non-zero. All the rows of all the entries of the last row are non-zero. If the tri-diagonal plus all the entries of the last row are non-zero, then what will the graph look like? It's a different graph. Simple cycle illama, you will have further edges. What will be the matrix A? Whose inverse is this graph? You can keep asking such questions. Okay? We asked such questions, we solved a few problems, 2-3 problems. Those are research problems. You solve 2 such problems, then you will get a PhD. You solve 2 such problems and publish, you will get a PhD degree. You know what a PhD degree is, right? So that's what I have done. I want to go to the last slide, just references. Any of the other things I will not discuss. Yeah, last slide, just references. Yeah, this one. So this is something that we published recently. It's a long paper, some 40 pages. Okay, so I'll stop here. I'll take questions, any question. Any question, not related to the lecture necessarily. I'll take any question. Hey, why do you think you attend such conferences? All along I have been talking. Yeah, so I'm going to pick someone. Okay, I'm going to get 5 of you to respond. Okay, so let me start with this girl. She has been very attentive, and so I'll start with her. So, question is, why do you think it's important to attend such events, and what do you think you will gain? Yeah, so perspective and contacts and exposure. Okay, exposure is the main word. Okay, be seated. So who is going to go next? Yeah.
Sir, I have a doubt.
Sure.
Did you rehearse at home before coming here? And if yes, how many times did you rehearse?
Good question. Kelvi purinjada? Okay, how many times did I rehearse? See, as a mathematics teacher, we practice a lot. So, for example, even for a course that I taught last semester, I won't straight away go to the class. I'll take a piece of paper and a pen and sit as though I am in the class. Then what are the topics that I have to cover? What are the examples that I have to do? 1 hour class na I prepare for something like 3 hours. No reference to any textbook. அது textbook முதல்ல பார்த்துருவோம். Then we'll sit with pen and a paper and do the class on the sheet of paper. Every proof, every step, we'll do it. And then go to the class. Okay. But the only thing is when you do this course two times, 3 times, then you know the main things. But appadi kuda, for a 1 hour class, I think I have to prepare for at least 1 hour. So you have to practice a lot. Now this is a research problem that we have been thinking, this is a research problem. It's for my student took about a year and a half to solve. So the student will come, something like twice a week and discuss, and we make incremental progress. Or chinna problem, how do you resolve it? Today we will have a discussion of 2 hours. Which means every aspect of the problem is there in the back of the mind. So we know the whole thing about this problem. It's at the end of the day my research paper. So I know the whole thing. But how do you do the presentation? You have to practice. Practice actually means hard work. You have to work hard. To achieve anything, you have to work hard. So I practice a lot. And then, see, I have been a teacher for 30 years now. So you gain, your vocabulary improves, and you know how to put it to the student, what kind of audience you have, and if someone is talking somewhere, and how do you focus on the others, and things like that. So you learn so much because you have so much experience now. But practice. Mathematics lo or problem irukku. If you take it for granted, you will pay for it. For example, I make mistakes towards the end of the class. Towards the end of the class, I see the time, I feel I have to finish the class within that, finish that particular thing, the last item before the bell rings, before the next class starts. That's precisely the time I make some mistakes in the class. So that also happens. Okay, but I have overcome that over a period of time. T20 la pandra mari dhaan. See, T20 you don't have time, so just any ball is to be hit. You make mistakes there because there is a pressure of time. But you overcome all that by way of practice. So you have to practice a lot. Okay, now, அந்த பக்கம் தம்பி 1 2 3 from the left நீங்க தான். இது இந்த மாதிரி ஈவெண்ட் வரதுனால என்ன பிரயோஜனம், ரைட்? தட்ஸ் a cynical question. உங்களுக்கு என்ன தோணுதோ சொல்லுங்க. எதுக்காக வரணும்? உங்க கிளாஸ்ல, உங்க காலேஜ்ல உங்க டீச்சர் அனுப்பிச்சாங்க. So you have no choice. She forced you to come. சொல்லுங்க. ஹலோ. Whatever comes your mind doesn't matter. உங்களுக்கு ஒன்றும் மார்க் எதுவும் போட போறது இல்லை இப்போ. சொல்லுங்க, இந்த மாதிரி ஈவெண்ட்ஸ் அட்டென்ட் பண்ணதால என்ன பிரயோஜனம் from your point of view? ஏய், சும்மா மர்மர் பண்ணாதீங்க. கம் அவுட். மைக் வேணுமா? So what is the response? It doesn't matter. யார் என்ன வேணா நினைச்சுக்கிட்டோம். சொல்லுங்க. ஏய், லிப் சிங்க் மட்டும் கொடுத்தா போறாது. Just lip is moving. You have to tell us what. Okay, someone else. அந்த கோடியில last but one bench. Anyone? What is the use of such events? Why should I participate? Suppose you ask that question yourself, then what will be your answer? யாரான ஒருத்தர் சொல்லுங்களேன். Yes, please. See, for example, after listening to my lecture, what did you learn? What is the use? மனசுல தோணுன்னு சொல்லுங்க. See, as I told you, nobody is going to give you grades, marks, etc. You will anyway get a certificate, participation certificate. So you don't lose anything. சும்மா சொல்லுங்க. It doesn't matter. Nobody is going to judge you. from there. சரி அப்போ அந்த பக்கம் at least one more, some response. See, why should it be that I give the talk only, I keep talking all the time and you should listen? You should take revenge when the opportunity comes. So, you, second one from the left. You know sankochapata appdi. I mean, this is, yeah, go ahead. தெரியாது தெரிஞ்சுக்கிறது. Okay. Anything else? Okay, so that is some exposure. See, you keep getting, see, you keep listening to something, then you will feel more and more homely. So that, you know, you will be, when an occasion comes, see, mathematics is a whole. அப்படின்னா என்ன அர்த்தம்? Mathematics you can't differentiate between applied mathematics, pure mathematics, differential equations, real analysis. Mathematics is a whole. Anything that comes your way, you have to take it. ஏன்னா நீங்க ரிசர்ச் பண்றீங்கன்னு வச்சுக்கோங்க, you won't know what you will use, what you will need in your research problem. So keep your mind open. Keep your mind open to any idea. And it's a lifelong learning. Lifelong learning in math. And lifelong learning in experience in life. Adum lifelong learning da. We never stop from learning. I've taught 30 years. I never stop learning. There are so many things to understand, so many things to learn from others. So we need to keep the eye open, keep the mind open. Mathematics சுத்தமா இந்த லெக்சர்ல ஒரு கான்செப்ட் கூட புரியல. You don't remember anything. It doesn't matter. But there is something. Practice, hard work. That is something which I think you should take as a lesson. And the madri. So for every individual, there is something to learn from any experience. Don't miss out. Keep your mind open. So keep your eyes open. Okay? Yeah. Any further questions? Yeah. Yeah. See, all these. See, we are talking about the inverse. So it's a square matrix. Pseudo inverse lo kuda triangle property is for square matrices. Yeah. For pseudo inverses, what is the answer? So, but adu square ah thaan irukum. Pseudo inverses is a notion that is possible to define for a rectangular matrix. We can talk about the inverse of a rectangular matrix. Adhu determinant calculation kadayadu. Okay, there is some algebraic definition that is required. It's called pseudo inverse. And the pseudo inverse is very much related to a regression problem that you solve in machine learning. Yeah, so linear regression is least square solution. And see, basic mathematics is useful always. Basic math is useful always. Artificial intelligence neenga pandradellame math, so much of probability, so much of linear algebra, so much of computing. Computing is just math. Writing a computer program is just math, logic. So math is absolutely fundamental. Being a student of math, it's like a blessing, varam. Don't miss out. See, you get good salary. That is always guaranteed. You will also enjoy something. It's like listening to a nice movie song if you want. You like a lot of movie songs, right? So you like a lot of movies. It's like enjoying a movie song. When you solve a little problem in math, it's like enjoying a movie song. The pleasure that you get, you won't get anywhere else. You will also get a reasonably good salary. Don't worry about that. Life is taken care of, provided you are prepared to work hard. See, highly competitive world. Okay. See, there are about 100 of you, maybe 70 of you. There are people who can't, who don't have the opportunity to sit like you guys. They won't get one meal a day properly. In the mari chance avangala kudutheenaka, they will chase you away. they will chase you away for every seat here. அந்த மாதிரி இருக்கு நம்ம country. So when an opportunity comes, அதோட வேல்யூ நீங்க புரிஞ்சுக்கணும். There are so many people, you know, that see, for every seat here there will be 100 competitors. If they just know that there is this opportunity, for every seat here there will be 100 competitors. So it's a very competitive world. The only way to go through to be successful is hard work. Hard work. Okay? முயற்சி திருவினையாக்கும். Hard work is important. More than my lecture, lot of advice. Because I thought the basic problem I should define and then forget the research part. But some exposure, some introduction. That is the purpose. Okay? I think I'll stop here. Any questions? Any?
Any questions from the participants? Thank you, sir. I would like to express my sincere thanks to Dr. K.C. Sivakumar, Professor IIT Madras, for his excellent and insightful presentation on tridiagonal matrices. This lecture was truly enlightening, and I'm confident that all the participants will be greatly benefited. And thank you very much for the motivational speech, sir. And I've attended many many reference or any paper while taking the class. Put it on the board with a clear explanation and everyone will understand it well. And I watched many NPTEL courses also, sir. So I advise everyone to watch those courses and get benefited by them. Thank you, sir. Thank you. Thank you. Session will start in another 5 minutes. So stay back. Those who are presenting the paper presenters can go to Krishna block. Only paper presenters. ఇది పెళ్ళ ఇండియా just give me a place. Okay.
Yes, sir. அட்மிட் இல்ல சார் இங்க. இல்ல சார் இங்க. எதுல அட்மிட்? கொடுத்துட்டாங்க சார்.
Yes. Yes. No issue. No issue. I can do it briefly according to your time schedule. No issue. Right. Yes. Right. So, may I share my video? Sorry, the screen. All right. Okay. Thank you. Right. Can you see the screen in full screen mode? Okay. So let me. Now you can see the screen. No? All right. So I think some issue with the full screen. Shall I go with this enlarge mode? Or should I? All right. Okay. So I will enlarge the thing and move it. All right. So some sharing with the full screen. So let me just adjust the window.
So is it okay this size? All right. Okay, so this is my topic today. So first thing, I should thank you for inviting me for this talk. And I am basically going to talk about this spatial autocorrelation as the context here. So as a research type of orientation or a direction, I will go through this application of spatial autocorrelation in analyzing and modeling epidemics. I think you all know about epidemics, where we consider the rapid spread of infectious diseases most of the time in the community level, almost like this COVID-19 thing. So there might be infectious agents that getting this transmission done. For an instance, COVID-19 is spread by a virus, and dengue is also from a virus. If you get tuberculosis, it is from bacteria. And if you get malaria and filaria, it is through a parasite. Likewise, some infectious agent, microorganism will be involved. And these epidemics, actually, the rapid, even the normal influenza is there. Because of this rapid increase, the escalation of the transmission, we have to control, I mean, the health personnel should control those spreading by considering the spatial matters, not only the time component. Because, I mean, the best example is the recent COVID-19 thing. So if you want to control the disease, we have to somewhat control the mobility. For that, we should consider the space. For an instance, let's say from one state to another state, sometimes we have to close the border between the districts also, even between certain cities and villages. Sometimes we have to block the entrance. So that means space is related. So if you are living in a state or some territory, some spatial unit, where your surrounding, like neighboring units are having much more infected people, then you are at a risk, because you go to those regions frequently, and those regions having higher infected numbers. That is why this space is a matter. So we have to be carefully handle these space related controls to control such kind of a epidemic. Right? So that is the research type of, I mean, the motivation towards this thing. For that, I will take this spatial autocorrelation as the tool to make that analysis, to make that modeling part. So therefore, this presentation basically targeting that autocorrelation matter, and then some focus about this idea. Right. So let me go through just like outline first. So I will first introduce this spatial autocorrelation. Then I will go into one component of that part as spatial weights. After I introduce the definition, you can see it. And then we have some characterization. That is the important matter later. Because we are going to see these spatial units as clusters or sometimes just dispersed according to some measurement in diseases, yes, according to the infected numbers. And then the fourth one is some kind of a graphical view called Moran scatters plot. Here this word Moran I will introduce, that is one index where we can use in this spatial autocorrelation. So later we can come into that part. And finally, some incorporation about this autocorrelation matter into the modeling aspect. So that is my target. First thing, I will basically introduce what is meant by the spatial unit. You all know. These are the maps. So left hand side your country, Indian map is there. Right hand side our small country, which is not into scale. So you all know that Sri Lanka is very tiny island. So anyway, my point here, see these locations like demarcation. Indian map having the state borders. Our Sri Lankan map here we have district borders. So if you are living in one state and moving into another state in a disease period, so then you have have to evaluate your risk situation. As a country also, the health personnel, policymakers should keep their attention with this spatially monitored disease transmission. Right? So just think of that. And here the first keyword that you have to see is the spatial units. By that I mean certain spatially related locations. They might be states, they might be districts, they might be cities, even villages. Right? So that is the first thing to look at. And then we'll directly go into this matter of spatial autocorrelation. I think you have heard this word autocorrelation in the sense of time series. And you have the separation, like different idea as cross-correlation as well. In cross-correlation, we try to see some similarity between two time series with a lag. Between two time series in cross-correlation. Right? But in autocorrelation, we see some kind of a relationship with its own lagging version. Right? The same series, but with certain lag. So then the same series we compare with itself, but with a lag. So that is the matter behind autocorrelation in time series. But our focus is not time series, but the spatially related thing. So therefore, we have to look at what is meant by the spatial autocorrelation. For that, we should see the similarity. You can just see this introductory paragraph coming here. The spatial autocorrelation describes the extent to which an observation, let's say the number of infected people as this observation, at one spatial unit is similar to the observations at neighboring spatial units. How similar they are. In autocorrelation, we see how similar the lagged version with the original version. In spatial autocorrelation, we basically see how our observation in one location is similar to another location. Right? Patterns should be recognized. In time series autocorrelation, we might say if it is having like increasing, let's say today some observation is there, next day it is increasing, and that pattern is like continuously going ahead, then we might say it is positively autocorrelated. Positive correlation is there. On the other hand, today increasing but tomorrow decreasing, alternative kind of aspects, patterns might be coming. So then we say it is like most of the time negative autocorrelation. Kind of thing is associated with space matters as. For an instance, before going into this formula, I will tell this. Now, let's say your observation is like almost the same as your neighbor's observation. So then you are in a cluster of these observations. You are in a clustering kind of a mode. But in some cases, your observation, your spatial unit having higher numbers, but your neighbors are having lower numbers. Right? So likewise, it might be then alternatively like diversely spreading there. So then it might not be that clustering effect. It is almost like a dispersion or kind of a random pattern. So kind of like categorization is there. So we should eye on that also, because if you are living in a clustering occasion, your risk might be higher in a disease transmission, but in dispersion, somewhat low risk. Right? So that is the final matter to look at. But now let's see how far we can tackle this autocorrelation matter, this similarity thing, using a formula. For that, the well-known and the frequently used index is called Moran's index. Moran's I, usually that is the term that we call Moran's I. So this was introduced by a statistician, Australian statistician, Patrick Alfred Moran, in late 1940. He introduced this formula to catch this autocorrelation matter in these spatially related aspects. And later, now you can see even here 2 bullet points. Global version is there and local version is also there. I will explain the formula later, but just see the global and local effects. That means global, yes, the whole context, whole country, whole spatial collection will be taken.
But in local thing, yes, even we can think of one spatial unit, but related with other neighbors, but you are not considering the overall aspect. What happens to the others, you don't care. You care just what happens to your location, then it is local, right? So then this local aspect, local version actually got into much attention later in 1990s around that, right? So it was like motivated by a person called Luke Anseli. He is a person who did his research work in spatial matters, but most of the time related to econometrics. He actually promoted this version of locals model. So that is a bit of history. Now let's come to this formula. If you look at the globals Moran I, you have these two sigmas, but within that you can see a factor called xi minus x bar, xj minus x bar. So this xi at the bottom you can see xi denotes the observed value, whatever the variable you take. In our case, infected proportion or infected number of people, let's say, because we are keeping our applications with epidemics. Right. So that observation is denoted by xi, and x bar is the mean value of these cases. If you take all these spatial units, right? So xi denotes the observed value at spatial unit I. So I is referring to your province, your state, your district, whatever your spatial unit, right? Then by these two factors, we make the gaps xi minus x bar, xj minus x bar. So see, let's see you are in the ith location. So then you consider the gap with your mean, and other locations are there with these xj's. There also you keep this gap, and you multiply these gaps and taking the summation overall with the connection or influence with wij as well. This is very important, this weight parameter wij, because it refers to the nature of your connection. For an instance, let's say you are just keeping the adjacency. Then you can say if location I and location J are connected like by the common border, then you can keep this wij as 1. But if they are not connected by a common border, then you can keep it as 0. Then every thing coming in this formula vanished if you are in a non-neighboring, non-adjacent case. But adjacent cases are taken together. That kind of role is played by this wij. In the next slide, I have a diagram figure. There I can explain it more. But just see, now this lagging effect is taken by this gap of the observation with its mean, along with keeping this wij, which associates two locations together. Right? So that is why we consider this as a measure for a spatial auto-correlation. Right? The same spatial setup is there, but we make some kind of a lag with others with this association of weight. And the division by this x minus x bar square thing is there, almost like taking this variance type of aspect. And in front of these things, you can see n number of observations divided by the summation of these wij's throughout the spatial width. So it is somewhat like taking that the relative nature of the wij's just to control the thing with these lengths. Right. Local version almost the similar, but you can see our two sigmas reduced into just one single sigma, keeping out that xi minus x bar thing, but we keep just xj by xj minus x bar because we concentrate only on one location with its neighbors or with its connection with others only. That is why. So keep in touch with that for the moment. Now let's go into that aspect with these cases. First, I will introduce before the figure that I mentioned. Let me introduce this nature of the wij's. One thing I already mentioned is first bullet, adjacency type. If I and j, the units are shared in the common border, it is 1. Otherwise, it is 0. Right? So that kind of association can be taken. Or else, this is the more practical one. You can propose a weight between I and j according to the distance between those two spatial units. Now you might wonder how can you make a distance between two districts or two states, because so many locations are there. From where to where you take the distance. So for that, you can define or you can like select one point to represent your state as a localization. For an instance, the main city of that state you might take. Main attraction point in the mobility you can take. Let's say commercial city in your state can be taken. Because in epidemic kind of cases like this, mobility is playing a very important role. So therefore people like the mobility is mainly connected with these main attracting points in the state, main cities. So therefore just select one location that is important for the state, and then from the other state also similar type of location is there. Then you can measure the distance between those two. Well, Euclidean distance might be enough, right? So then you have somewhat kind of a relationship between those two regions to say how far you are with your neighbors, right? So if you take that DIG as the distance between I and J, then you can make your weight according to that distance. Usually you need higher weight if you are closer. You need a lesser weight if you are too far. So that is why we take this reciprocal mode. Bit of mathematics there, I mean very simple. 1 over Dij into the power k, even you can raise it into a power. So this might depend on your experience, on your way of handling the thing, right? So keeping something, but 1 over the distance matter is there. Or else, even you can produce some kind of exponential decaying effect like this third bullet point. Minus alpha Dij representing that power, Dij running again between for the distance between I and J. So if you have higher distance between two units, then your weight is lower in this process. Right? So by taking that weight, you can connect it to that autocorrelation form. Right. Some diagrams and some features are coming in this slide. Now, according to this Morales I mean the global one, we can categorize certain scenarios. Now you know the Morales I measuring the similarity of some observation with its neighbors, with its other associated spatial units. The index typically ranges between -1 and +1, almost like this Pearson type of things in correlation measures. So these typically, but there might be like extreme cases, but most of the time it is like ranging between -1 and +1. If you have this one as positive, I mean from 0 to 1, then our patterns are getting like clustered. This is the connection. That means high observation areas are surrounded by high observations, but low observation areas are surrounded by low observation. Low surrounded by low, high surrounded by high. This is called positive autocorrelation, spatially positive autocorrelation. So then our I, the Morans I, the index, is more or less in the positive side, greater than 0. Otherwise, we have a case like less than 0, these similar values are spatially dispersed. Right? Earlier, similar values clustered, but now these similar values are spatially dispersed. High surrounded by low, low surrounded by high, they are just dispersed. Right? So just the connection is taken by this chessboard, it is better to represent. See this first diagram, all the top cages, boxes are colored in blue, lower cages no color, white. So this is like fully clustered type of version. Think of that blue colored cases are representing high incidence, high observation, white are low observation. Then high are clustered by high, low are clustered by low. So this is some extreme scenario of positive autocorrelation. But the second one, it is more into the negative autocorrelation, negative side of I, see the dispersion. Blue are like systematically dispersed around white or the other way. White dispersed around blue. So then it is exactly the chessboard pattern. This is in negative autocorrelation, where high observations surrounded by low one and low cases are surrounded by high. The other case is, yes, the random effect. More or less different patterns might be getting together, but you can't see a full dispersion, even you can't see full clustering. So then these are a bit of like random effects. So then your Moran's eye behaving around zero, not into the extreme of -1 or +1, but behaving around zero. So that is the measurement that we can transform into this spatial idea. Then we have a diagram here coming with Moran's scatter plot. This is like giving the idea in a different perspective. This is taken from the same Moran's eye index, but catering x-axis into this measure of xi minus x bar. This was included in Moran's eye. And so-called spatial lag wij xj minus x bar into the y-axis. So I'm going to make a plot. So this is wij, this xj thing is called spatial lag, right? Because we are considering what happens to the other observations xj as a gap with x bar, but along with our weight, because it will take our association. Whatever the measurement you take, but wij taking that association with others. So it is like weighted average of neighbors. So this is in the y-axis. So if you take these two parts out of the Moran and getting a plot for observations, it might have these kind of scenarios. First figure here, left hand side one with these red dots. You can see x-axis, y-axis, they are representing these two as I mentioned. Then if you locate your each observation by a dot according to this x figure, x coordinate and y coordinate. See here, the first quadrant is taken with high. That means x-axis value is high, y-axis value is also high. High means at least just think of positive signs, because we just like standardize it with zero. So you can learn these things by looking at more reference. Anyway, high in the first quadrant, but the other dots coming more or less in the low. Both the third quadrant. This is the low case, because x values are also negative, y values are also negative. So low. So that means our figure is almost done with high cases and low cases. That is the clustering effect. High numbers are getting together, low numbers are getting together spatial. So then we have the positive autocorrelation. The important thing is, if you draw this regression line on this bullet point, it is having a positive slope. So this can be like interpreted by the Moran's formula decomposing into this regression idea. And the other hand, in the right hand side, you can see this green colored thing, almost all lying in this LH and HL things, second quadrant and the fourth quadrant, giving this regression line a negative slope. That is negative autocorrelation. That dispersion effect is there. And then I will go into another diagram. This is more ideal to see the spatial units and their numbers with some incidence or observation. See, just think of this region separated into few other cases, almost like 20 regions located here. So that means this whole region is separated into 20 spatial units. This is not a real map, just a simulation. But carefully see, some of the regions are marked by a bullet of red color and others are in blue color. And just think of this bullet located in one attraction point that I mentioned earlier. Let's say it is the main city. Or sometimes even you can geographically think of some kind of a middle point, a central point of that region. In that way also you can keep it. Whatever the location, you can now see some of them are red, some of them are blue. Just think that red dots are having higher observation. If you go to this table, again, this is a simulated one. This red color region, let's say these are 2 and those are 1, these things having high number. Let's say infection value, infected number of people in hundreds or in thousands, let's say like that. They are with higher number. But this blue colored one having lower numbers like this 7, 1, 8 into the latter part of the regions are 15 up to R20. We just manually put it. So just think of like low numbers in infected number of people. Then you can see in this diagram, red dots are coming in one corner, one side, almost left-hand side upper, and blue dots are coming in the other direction, the right-hand side lower part. Right? So that means it is clustered. High incidence cases are clustered together. Low incidence cases are clustered together. That means in the Moran's aspect is positive autocorrelation, positively related one. So you can check it by measuring your Moran's I value. We took the value as, we got the value as 0.74202. So it is, and it is more into the side of 1. So if you are like lying in this region of 0, 1 in the Moran index, it is more into positive autocorrelation, and this is now even more like close to 1. So then this positive nature is taken. So that is about this nature of the Moran's I. And you can test it with different ideas like different localities and different assignment of values. You can check it. So my idea here is to introduce the behavior of this Moran's I value according to these spatial variations, associations regarding some observation. And this is somewhat about like checking the distance, because in a practical application, we need to measure this thing, as I mentioned, even in Euclidean sense or even the geodesic kind of things, you can just think of that. But anyway, see here, this Dij marked for this straight line segment between these two regions, R5 and R12, as the distance. So that distance matrix is important to make our weightages, Wij. That is why I just put this metric, just, I mean, don't bother about the values here. But you can see the values between each two region, R1, R2, the diagonal coming 0, because we do not measure, I mean, we don't have a distance between the same location with itself, no? So that is why. So, but R1 with R2, R1 with R3, likewise for every 20, we can, every 19 other spatial units, we have this. So based on this distance matrix, you can, it is a symmetric matrix, because no direction to the distance. Yes, we can mobilize in the direction, we can take the mobility in a directed manner, but distance is not directed. It's an absolute measurement. So according to that, we have this distance matrix, and then we can convert it into a weight matrix according to the proposed cases, depending on Dij reciprocal types or exponential types. So I just want to make you aware about measuring the distance and making it into a weightage from this slide. And then we have, yes, it was given here also, distance based, you can look at and see how these associations are kept. And then I have this final slide. I have some more. I will just go to those two cases later. One chapter work is there, one publication is there. Just to elaborate few more matters. Otherwise, this is the final slide from my slideshow here. Here, this Moran's I value can be directly incorporated into our modeling as well. according to the Moran's I value, you can do some kind of analysis between your space units, right? Whether it is getting clustered or dispersed. On the other hand, with the modeling aspect, you can incorporate this parameter Moran's I into the model. For that, we need bit of mathematical tricks to do. Because Moran's I is ranging from -1 to +1. That means it is having a chance of getting negative values as well as positive values. So if you are making it to a parameter, it is better to have it in one side most of the time positive. Otherwise, you can't tackle the dynamics properly in a formula. Usually, we assign positive parameters. If you really want something to be negative, yes, we can put the negative mark in front and keep your parameter positive. Right? So therefore, we need to do this like minus plus case into plus only. For that, we have a simple transform. I plus 1 divided by 2. Then every value, the usual -1 plus 1 range, coming into the range of 0 and 1. So then it is coming into the positive side. So that is one tactic. The other thing is now you can see the extremes like k goes to 1 means we are in the positive autocorrelation, that means in the clustering effect. K goes to 0 means we are in the dispersion aspect. So in epidemics, this clustering is the risky one because we are surrounded by more risky regions. So therefore, we have to think of like risk or the transmission is getting higher if you are in a clustering situation, but it might be lower if you are in a dispersion kind of effect, dispersion. So therefore, in a time scale model, you can include this spatial matter as a parameter coming from the Moran side. So that is given here for a simple SIR model. You all know this susceptible infected recovered compartments in epidemiological modeling. Here, S dot I dot R dot running for their rates, and this is the classical example of SIR dynamics. This SI multiplication is there just to represent the interaction between susceptible and infected. And infected numbers getting high if you have more interactions. That is why this SI is influenced as positive manner here. So then the removal from susceptible taken as with negative. And this mu is introduced just to like, let's say something like death rate to remove those people. This lambda is running for the force of infection, people coming into the susceptible category through the births. And then the recovered class is also there, right? Infected people getting removed into the recovered compartment. That is the classical type. But if you carefully see, we have this additional parameter k to represent our spatial matter. Right? This can be allocated even region-wise if you consider the local matter, but globally also. Let's say for a certain period, you keep one of your Moran index value in this model. So that you can take this global Moran value into the model like this k. This is only one example. In addition to this infection rate beta, you can keep that k as well. Then higher k, that means clustering effect influencing more into the transmission, but lower k is like demotivating the transmission, right? So it is like acting as a fractional parameter where lowering or like increasing your beta into certain levels, right? So decreasing or increasing kind of levels for your beta. That kind of a role will be played by this K, but importantly, K is taken not by the time scale dynamics, but spatial unit dynamics, right? Spatial autocorrelation. It is a one-time calculation actually, but let's say for a certain period, you can keep some value. Let's say for a month, we take the average number of infected people as our observation, and according to that, we can measure that I. So that particular value can be incorporated. And then time to time you can like change this. Let's say for the next month you can propose a different thing. Meanwhile, you are running with the usual SIR time. Likewise, you can adjust. Right? Important matter is without much of like uh, difficulty, you can easily incorporate a spatial autocorrelation type of context into a usual dynamical model. That is the motivation key. You can extend this work with different ways of keeping this K into here. Actually, research work going on in our research team regarding this, because once we check with the literature, these things are very rare, like spatial analysis modeling done, but keeping it with the models, even like just to separate this no correlation matter is very rare. Some spatial modeling is there, it is not rare. But keeping this type of autocorrelation measurement directly into the models and then doing some analysis, sensitivity analysis, bifurcation, stability analysis, and even optimal control, that part is like that sort of context is not frequently coming in the literature, right? So therefore, get motivated with regarding this. For an instance, our area of research during this period is doing some optimal control matters regarding the epidemic by incorporating this Moran's eye as well. So we try to derive certain results, certain, let's say, ranges, certain equalities on this Moran's parameter to keep certain things, let's say stability, to keep the stable nature kind of things are there. For optimal thing, yes, we can propose what should be the range for K, this Moran's eye, kind of things are going on. That is bit of a motivation regarding that. Right. So likewise, think of that modeling type. Just to motivate more, I will just take 2 minutes more as your time, the usual timing is also over. Just to introduce these two publications. First thing, I think you can see this new screen. This is a book called One Health, Wiley publication, edited by Professor Mektika Vitanange, Sri Lankan scientist, and Professor Majeti Prasad, you can proud of him, Indian scientist. They edited this book on One Health, Human, Animal, and Environment Health. In this book, he published one chapter coming with this title. I hope you can see it, but try to enlarge it. Just a few matters only. You don't have to follow everything coming here. Just see the title is Spatial Temporal Dynamics of Disease Transmission. That means we are going to consider both time domain as well as our spatial domain as well. That is why we call it spatio-temporal of disease transmission. So here we did, if you can find out this chapter, my colleagues are here, Dipo Aldila and Karmya Putranija. So with this collective work, we did something around this spatial thing. I will introduce few like additional matters that we took. See here, you can make your maps colorable, making colors with the output of this Moran's eye results, just to show who are the spatial units getting clustered or dispersed kind of cases. So according to your observation and the Moran's eye, that can be done. And then I will show one important diagram coming here, where the local thing can be arranged here. These diagrams we already got that idea. These are about some selecting certain values on these weightages. So that is there. And this is something like like according to the time variation, we monitor what happens to our index I, Moran's I. So this is something new which was not there in the slideshow. See here, daily, this is about COVID-19 thing, daily basis of the Moran's eye. See, you can see this is like fluctuating, but like the most of the values are about to zero, positive side. This original Moran's eye, not the K that I introduced for the modeling. So it is more into the positive side. That means we can see this scenario is more into positive auto correlation. The clustering risk is there. Very simple analysis. Right? So that is one thing to show there. And even by that Morans scatter plot, you can make some like colors according to the cluster, sorry, the quadrant that we belongs. Right? So let's say, for an instance, if you are in high, you can propose the color red. Kind of cases. You can put blue if it is in low region. Right? So kind of mapping can be done. So it is, see here, high is with red, low is with yellow, low high is with blue, green is with low end. Right? So if you have that kind of a classification, then you can take that color into a map to show how your spatial needs are distinguished or separated with these risk levels. So then high means your Moran side moving positive side, positive correlation thing, and then having this higher risk. But low things are also there. It is not that risky, but still making your auto correlation positive because there is some lagging effect connecting with other neighbors as I will show one more diagram with a different publication. This is in Nonlinear Dynamics Journal. Research, reassessment of contact restrictions and testing campaigns about this COVID-19. Again, is spatio-temporal. My colleagues are there listed. So here you can see more detailed diagram, a figure I will show directly. This one. With these color codes, you can like localize, like the spatial units can be taken into the left hand side axis. Sorry, left hand to the y-axis. These are actually districts of Sri Lanka. The x-axis going with usual time. So then for each day, you see where your location belongs, which color representing your location out of those 4 colors. So then you can have this kind of a diagram. Then you can see this last one, Colombo, our main commercial hub. Most of the people living there, most of the people attracted there with the mobility. Major cities are located in that district, including our capital city, Jayawardenepura, and the commercial capital, Colombo. You all know Colombo. So then this red color, that means that during this period, the Colombo is into the positive autocorrelation clustering effect. If your neighbors are also getting higher values, that you are having this positive thing with red. But some of districts are almost like green, no risk, low. Right? So these most of these green colored are with less population, less mobility as well in the northern and eastern, some of the eastern parts of Sri Lanka. They are not that much of populated and that much of mobility is not there. So due to that, the COVID is spreading was not there. Their neighbors are also very having lesser number of infected people, kind of situation is there. So that is my idea to spread. Get this idea of spatial auto-coordination and then get the idea of this measurement Moranzai and then try to see somewhat like research-oriented presentation, research-oriented direction of ideas to interpret disease transmission situations, epidemic situations. So the motivated thing here is you can easily incorporate these spatial matters directly into your models running with usual dynamics. So that is the gap that you can look at and fill in your research work. So that's it from my side. So thank you for giving me the opportunity. And I wish you all the best for the rest of the work of this conference and your future work as well. So thank you very much. So that is from my side. Yes. Uh, yeah, yes. Alpha means it is coming in this, I think in the weight matrix, no? Weight. Here, I think you refer to this, no? It, yes. Two places, yes. Yes, that alpha is actually taking some kind of another parametric kind of situation. Because Bij, you can measure the distance between two cities. Alpha is running just to like keep your numbers intact, the other values of the modeling equation. That is why. Let's say you are, I mean, if you keep this Indian thing, your distance might be very high. So, but your like other values are very small. So then it is not compatible. So we can reduce that dimensional difference by keeping some alpha like a very less. You are keeping your dimension compatible by choosing a proper alpha. In this way, I think you are referring into this case. This alpha is coming in this e to the power minus alpha d. So then you can reduce that effect of dimensional change to be incorporated with your model. Thank you for the question. Actually, in the research cases, we tried with few cases and try to see what might be the best. So that kind of a case is coming in this chapter actually. That is why these figures are there. So then you might select somewhat like a proper value by keeping different options on these alphas and. Thank you for the question. Yes, yes, yeah, almost like that. Yeah, thank you very much, and I wish you all the best for the future activities by your institution. Thank you very much. Right. I will leave. Thank you.
இங்க எத்தனை வாலண்டியர் இருக்காங்க? கவர்மெண்ட்யா? கவர்மெண்ட் போய் சாப்பிடுறோம். இந்த சபையை கொண்டு வர பாரு யார் யாரு அது டோக்கன் கொண்டு வரான் ஒரு 3 டோக்கன் கொண்டு வரான் ம் க்ளோஸ் பண்ணுறேன் க்ளோஸ் பண்ணுறேன்
சரியா அந்த உட்காந்து வச்சு சாப்பிடக்கூடாது வாங்க சாப்பிட கேட்பாங்க சரியா சாப்பிடுறது வியாபாரம் ஒன்றும் சாப்பிட்டீங்கன்னா கேட்பாங்க வெளியில் போய் சாப்பிடாது அவ்வளோதான்
ஹலோ, கீழ வாங்க ஃபர்ஸ்ட் ஃப்ளோர் ஆடி வாங்க. இல்ல ஆடி இல்ல, நீங்க வாங்க, நான் சொல்றேன். ஏன்னா மேம் தெளிவா சொன்னாங்க, செகண்ட் ஃப்ளோர்ல எந்த இடமும் கிடையாது. இங்க we have AC, we have PPT. அதனால ப்ராப்ளம் என்னன்னா அப்போ அதான் செட் பண்ணணும். Like the problem was அவன் செட் பண்ண முடியுமா? ஓ புரியுதுன்னா ஆமா அது ஆக்சுவலி 4 பேஜஸ் கவர் ஆகாது. இது ஸ்டார்ட் பண்ணா கவர் ஆகாது. அதனால இன்னும் 4 பேஜஸ் போட்டுருக்கேன். அது ஆக்சுவலி ஏன்னா அவர் சொல்ல மாட்டாரு.
வந்தேன். பேக்ல மட்டும் இருக்கு. அரேஞ்ச் பண்ணு.
இல்லை மேம் இல்லை நம்ம பார்த்தோம்.
சரி, யாராவது ஒருத்தர் மிஸ் பண்ணுங்க. பார்த்தவங்க யாராவது நம்ம 2 மணிக்கு செஷன் ஆரம்பிக்கும் செஷன் ஆன்லைன் அப்படின்னு முடியல இன்னும் 6 பேர் இருக்கு. சரி ஓகே எடுத்து கேட்க அதான் சொன்னாங்க அவர்கிட்ட பண்ணிருக்கோம் ஆடிட்டோரியம் பார்த்து ஃபோன் பண்ணி கொஞ்சம் வர சொல்றேன் அந்த ஸ்னேகவா நீ வந்து கிளாஸ்ல பசங்களுக்கு சாப்பிட்டு உடனே எல்லாரும் இங்க வர சொல்லு வாலண்டியர்ஸ் எல்லாருமே எல்லாரும் ஆடிட்டோரியம் எனக்கு வரணும் அட்டெண்டன்ஸ் அட்டெண்டன்ஸ் இப்போ எடுப்போம்னு சொல்லிடு செக்ஷன் முடிஞ்ச உடனே
எக்ஸாம் ப்ராஜெக்ட் தான் இது என்ன ப்ராஜெக்ட் இந்த ரெக்கார்ட்ஸ் இன்னொன்று எங்க வச்சிருக்காங்க உங்கள்கிட்ட கொடுத்துருக்காங்க தெரிஞ்சு போச்சு எடுத்து கொடுத்துருக்காங்க பாயிண்ட் வந்து அவர் எந்த குறித்து போயிருக்காரு அடுத்த வழி தான் மேனேஜ் பண்ணா காலையில் இருக்கு சார் அது எக்ஸாம் அதான் சார் வீட்டுக்கு தான் ஓகே You continue. You continue.
காப்பி பண்ணிட்டு அப்படியே காப்பி பண்ணிட்டு
போர்டு வேற இருக்கு மேம். அந்த போர்டு வேற இருக்கு மேம். போர்டு வேற இன்னும் போர்டு வேற இருக்கு. இது கீழே காட்டுற போர்டு ஃபர்ஸ்ட் மீட்டிங் கம்ப்ளீட் பண்ணுங்க. கம்ப்ளீட் போயிருக்கு. நீங்க ஃபர்ஸ்ட் வீடு போங்க. நான் அந்த கான்ஃபரன்ஸ் நீங்க பார்ப்போம். TFB PPWR GNS.
இல்ல டெய்லியும் போகுது ஏன் டோக்கன் வாங்குறீங்க ஐஸ்கிரீம்